cloud. Okay, so is it recording now or not?
I believe
Yes, sir.
so.
It is now.
It is now? Okay. Yeah, sorry. So I thought I would do it, but I think it should be fine. Okay, so then what I was talking about, the evaluation of professor is done using these things, and also we have the professional service to the community, like you can become associate of a journal or program journal chair of conference and so on. So citation is important. If you write a paper, then it has to be cited in papers. But if lots of people cites, and it has a lot of impact. If very few people cite, then it may not have much impact. So that works on total number of citations, particular papers being cited, and other is called H index. So H index is becoming kind of standard metric, and the idea number that one number tells you that suppose if somebody is at H index of 50, which means that author has published at least 50 papers which have been cited at least 50 times. Okay, so he may have published 100 papers, but the remaining other 50 papers have not been cited more than 50 times. So if somebody publishes only one paper, have been cited 1,000 times, but his or her H index will be 1. Okay, because there isn't any other paper which is cited more, So it kind of captures the number of papers and also how many times those papers have been cited. So it's also depend on the impact factors of journals and conferences. And so you guys know the Google Scholar. That's the best way to look at it. Tells you the H index and number of citation. And also this is the best way to determine that particular paper you should really read or not. If the paper is not cited that much, then maybe, on the default, you should not spend too much time. So first start with the papers which are highly cited in your area, if you're looking at. So it's pretty nice metric, which helps you a lot. So now going to graduate school and becoming a professor or working in industry, the important thing is the papers. And that's what we are encouraging you guys to do research as an undergraduate, get exposed to doing research, and also then try the summary paper and maybe try to publish, because you need papers for everything. To graduate, your PhD, to get a job, to get a promotion, to get awards, everything. So before you write a paper, you have to be able to read the paper. So that's important. This normally I talk about this in the beginning, but since I have this, I want to go through this quickly. So the research paper reading is different from like when you read a newspaper or magazine article or a history, because this is a scientific paper, so you have to read several times to understand the paper. Okay, so maybe try to get a general idea of paper. You can ask, say, what's the problem being solved? What are the main steps? How can I implement? Because it's a computer science, computer vision paper. Because everything you have to at the end write a program to implement. And when you read a paper, so it's important not to get stuck on, something which you don't follow, and then you spend all day, a whole week. You just move on. If you don't understand, let's assume so that's correct what they are saying. Then what's next? Then you can come back and understand again, and you will know a lot. So also in science, I have found that it's important to relate what you know and what you read in the paper. So you can try to connect these things, and these connections are very important. Otherwise, if you try to understand, really stand alone, it's very difficult to get all these different papers in your mind and be able to come up with some new ideas. So it's good to look at what's conceptually different, what's conceptually similarities, what you already know, what is really new thing which you didn't know, and so on. And as you know, in all these papers, we have these different sections. You have an abstract, introduction, and related work, and method, and results, and so on. So typically, it's okay to skip the related work. You just get to the point. What's a method, and what are the results, and so on. And also, some people do mistakes that they just use dictionary to look for definitions of technical terms, because technical terms, they are not in dictionary. These are concepts. You may find something on the Wikipedia, but not in dictionary. So, sometimes it also happens that you can try to understand different pieces of the paper in isolation, but then you try to connect them. So as I said, the components of paper are title, abstract, introduction, rest of the paper. So these are the 4 important parts of the paper. And somebody said that one should spend equal amount of time on each of those. So which is kind of counterintuitive, because the rest of the paper has everything. But I think it's true that when people look at the title, they want to decide there whether they want to read on, or just they are not interested. So very good title, which maybe attract attention, which may be more meaningful, may be different, is important. So once they go to title, then they go to abstract. Abstract is very crucial. And introduction. So that is, I think, the writing of paper and doing a justice to these 4 things makes a difference. So typically the papers which get cited a lot, they are very simple, very intuitive to read, and people really enjoy it, and they get cited and they have impact. The papers which may be big breakthrough, but if they are very hard to understand, will have difficult time to have impact. So so introduction should be, what is the problem you are solving, and motivation, why it is important, why you are writing the paper about that. What is the state of art, how it is being done now, and what's the big deal about your approach, and what is your approach, in briefly in the introduction, and why is it great, okay? And then related work, then approach. And in the approach section, you need to have detailed method, different steps, so that people can implement results and conclusion. So this is what you should follow for your final report for your RU project. And of course, you have to put references. So now when you submit a paper, you can submit a paper to a journal, or you can submit to the conference. Now, review process for journal and conference is really different. So journal, there's no deadline. You can submit anytime, okay? And when you submit, it's assigned to what's called associate editor. And that associate editor, AE, will assign to the reviewers, and typically 3 reviewers or more. And this is single blind. So you won't know who are the reviewers, but reviewers will know your name. And then the reviewers will submit the reviews to the assessor editor, and so they will make a decision. They reject the paper, a minor revision, a major revision. Then you revise the paper and resubmit. Okay, then decision made, accept or reject. So then you submit a final version, will appear. Now, conference is a little different. So it's on a fixed deadline because conference happen on a fixed deadline. So it's assigned to area chair, which is very similar to assessor editor. Area chair assigns reviewers, but this is double blinded. So reviewers or area chairs will not know who the author is or authors are, and the authors won't know. So then reviewers will submit the review, and then the authors will have 1 week to rebuttal, to answer questions and argue and so on. Then the area chair typically meet personally and physically and go through the reviews, the rebuttal, and then make a decision. And then, typically 2 area chairs will make decision, reject, accept. So we heard, last week, we got 6 papers accepted in ICCV, and I think they were submitted in March, and we got reviews in, I think more than a month ago, we rebuttal and so on. So it's a process. The conference will be in October. So it's a long time, so basically almost, 9 months or something. And also this acceptance is reject. Most of papers will be rejected, about 70%, or accept as a poster or oral. So then you submit a final version and then you go make a presentation, the conference. Of course, this year will be virtual. So what are the good papers? As I said, easy to follow, simple to implement, high impact, which will have a lot of citation, which will increase the H-index. So now, what are the computer vision journals? The most prestigious journal is called IEEE PAMI, IEEE Transaction of Pattern Analysis and Machine Intelligence. Then it's computer vision, image understanding, Intelligence of Computer Vision. We have image and vision computing, and machine vision application, and several more. Computer vision conferences, the most prestigious conference, CVPR. Okay, so this year we had 6 papers, and that was held in June. And then International Conference, ICCV, it's every 2 years, CVPR every year, and this will be held, as I just told you, in October. And then European Conference on Computer Vision, ECCV. So these are the 3 main conferences. And then, of course, NeurIPS, which is the AI Neural Network Conference. And then other conferences are AAAI, ICML, ICLR, and so on. So again, the importance of the conference's impact factor. So I just wanted to share with you. I don't know if you knew that or not. Do you guys see now this my screen or not?
I still see the slide saying impact factors
Okay.
appearance on conferences.
Okay, I can share again. I wanted to show you this thing. So do you see now the impact factor?
Yes.
Okay, so this is the impact factor of the computer vision conferences. Okay, so CVPR, then ECCV, and then ICCV, and the PAMI, and so on. So the CVPR is highest here. And then let me see here. So I don't know why, how do I do this? Okay. So let's try again here. No. So wait, let's see. It's always a difficulty here. Let's quickly. Okay. So now let's try again here. Okay, so this one is do you see the screen? No, don't see it. Okay.
Yeah, we see it.
Okay. You see here the screen. Okay. So you see the Google Scholar top application?
Yes.
Okay. So this is shocking, right? So this is the impact factor of all publication venues in all sciences. Physics, chemistry, math, biology, everything. And of course, you guys know Nature is number one, okay? So it's very prestigious. New England Journal of Medicine is second. Science is third. And CVPR is fourth. Actually, it used to be five. Last month, now it became four. It's amazing. So in all science venue, CVPR is number four, which is, shocking. It's a conference, okay? So that is where you are. You are very fortunate to be doing the research experience in computer vision. And that's what you have to realize. Okay, so let's get back to this thing here. And I hope you will have papers in CVPR. So let me see here. I think I should end it here. Let me go to now next thing. Okay, so that's quick way, and let me now share with you the other presentation so that we are on time. Okay, so I'm looking for this thing here. Okay, very good. So here we go. Okay, you see this presentation, some thoughts on graduate school?
Yes.
Yes, okay. Do you see the slideshow, the presentation mode, or you see the other one?
I see the full slide.
Full slide, okay, good. So this is the undergraduate student I work with, Corey, and he prepared the presentation, and it's very nice. I keep repeating this every year. So, so he's saying that this is a quote from one of the professors at CMU. The PhD is a tremendous opportunity. You get to pick an advisor in any research area you like, and then you get to do research in that area, receive mentoring, think deeply on problems, publish papers, become famous while paying zero tuition for 6 years and receiving salary. So that's what the PhD is about. And then he said he forgot to mention the travel. So, you'll get a lot of opportunity to travel. And actually he asked me that, I should tell the travels I have done in that year. And this is the list. So I went, I gave a talk in Notre Dame University in January. Then I went to California. I gave a talk in UC Santa Barbara, UCLA, UC Riverside. In February, I went to Monterey. There was workshop on REU, PIs, Monterey, California. In February, I also went to Rome, Milan, and Italy for conference or workshop. May, I went to Princeton, New Jersey. We had this project meeting. May, I went to Clemson University. In May, I went to Dublin. I gave a keynote talk. Then May, I went to Washington and attended a DARPA meeting. Then June, I went to CVPR in Providence. And I went to Zurich to give a keynote talk. Then I went to Nice, France for PhD defense. July, I went to Washington to give a talk. And went to Dallas also in July. Visit Texas Instruments. September, I went to UCLA. Then October, I went to Florence, Italy for the CCV. So in December, I went to Hong Kong, Singapore, and Pakistan. So these are all travels 2012. But then I thought maybe this is too old, so I came up with this list yesterday for 2019. So of course, 2020, we didn't have any travel. So in January, I went to Hawaii. There was this winter conference on computer vision. And then March, I went to Oslo, Norway. They invited me as distinguished speaker. Then June was Long Beach, California for CVPR. In September, I went to Taipei, Taiwan, gave a keynote talk. In September, I also went to London for an invited talk. In October, I went to Nice, France. I received this Technical Achievement Award. In October, I also went to Seoul, Korea, ICCB. And also went to Amman, Jordan, keynote talk. November, I went to Houston, went to Tampa. Then December, I went to Abu Dhabi, UAE, and also to Australia. So then, there's a lot of chance for travel, and all these are, covered by this university or by whoever invites you. So now thoughts on grad school, why? So character traits of potential graduate student, you love to discover through research. You connect well with your professors. You love to teach others. You don't care if the problem doesn't have solution. And, graduation ready. And a potential industry worker, if you go get a job after BS, you are eager to redeem your degree for a good job. You simply enjoy coding. You are burnt out. And why you should go to grad school. So he's making a joke, saying, no, mom, not a kind of doctor. So it's engineering grad school. It's not like a medical law or MBA school. Emphasis on discovery, research, not learning. Grad students typically get paid tuition and educate living stipend. So most of the students actually don't know that they don't have to pay for graduate school. It's all covered. And so there's another quote from CMU professor say about graduate students, say they are smart but naive. You have to be careful not to tell them that the things we are expecting them to do are impossible. So remember, in these meetings, I've been giving you a hard time and pushing you, and that's the idea that in research, we expect a new generation, next generation of the researchers like you guys can do the unsolved problems and do advance the state of art. That's the way science works. So then how did he get in he went to Stanford for his PhD. I think he must have been done now. So what is important? So research is important. That's a very large font. That's what you are here. And then statement of purpose is important, as I told you, that you have to write, why you want to do PhD, what you want to work on, and so on. And of course, GPA is understood. You have to have high GPA. And letter of recommendation, and some work experience or internship or teaching, GRE scores. Where do you apply? Start with the US news and ranking and browse lab websites, ask your advisor. Best school don't have lowest acceptance rate ratio. When do I start? And start preparing somewhat before. How many schools? As many as you have time and money for the applications. And the fellowships are important. And this is a very golden opportunity to get into top school. And it pays you a lot of money. And if you win schools that rejected, well, let's say you will call you back. Actually, he got in before he heard about fellowship. He applied to Stanford, he got in master's program. He actually wanted to do PhD. So once they knew that he got a fellowship, they admitted him directly to PhD. So so that's what about, you will hear a lot about this NSF fellowship. And he's saying, how did I get in? He wrote an honors and major thesis, 2 conference paper, 2 first author papers. He was teaching and leadership experience, letter from researcher advisor, average GPA, below average GRE score. Still you can get in. And he got an NSF fellowship. And these are at that time, the acceptance rate he applied to these schools. And so these are the resources which, I will give you copies of all these presentations so you can look at those. Okay, so that's just one. Then I have another one also, which is pretty good, which is from Enrique. Okay, so here we go. Let's see. Do you see this now or not?
Yes, the Enrique G. Ortiz.
Okay, good. Applying for fellowships. So tips: find a fellowship buddy, make a time, do your homework, visit university fellowship office, narrow your focus, know your audience, and recommendations. That's important. So find a fellowship buddy and make a time, start early, make scheduled calendar, spreadsheet, just write, do your homework, find all fellowship you are eligible for, note all of their requirement, find out exactly what they are looking for. And as a graduate fellowship has these things, intellectual merit, broader impacts, and you will know more about this. I think they keep changing. So I think I'm going to skip these because you will hear a lot about these things. Visit University Fellowship Office, most important resource, because they have experience, previous submission, resources, and narrow your focus. Find a proper project area to focus on. I think for you, it's easier because you have done in computer vision research experience. So that's a default, unless you want to, do general AI or some other. And it's not important that what you write, ultimately, once you get in, you'll do exactly that, because you may change, you may meet different professor, you take a class, you change the area. But this is just that you have a plan, and so that, you are capable of expressing what you want. So you want to check the existing literature, make sure you have a hypothesis what exactly you want to do, and you know your audience, write clearly, read it, because people who will review, they are not necessarily computer science, and they're all over different areas. And font size, the number of pages, and so on is important. Use figures and graphics where appropriate. So recommendation letters are very important. You will hear this again and again in this letter presentation. Have a backup, and if you don't get in, first time, try next year. I think they give you 2 choices. So, and these are the, different links which you can use, and I will send you these also. Okay, so I have one more, then I'll finish. So where is this one here? Okay, so do you guys see this one called fellowship information? No? Okay, let me try again. Okay, do you see this called fellowship information?
Yes.
Okay, so this again is a bit old list, but I think we want to give you as much information as we have. So some may have changed, but I think it's better to have everything. So this is actually was compiled by our current dean. He was a graduate coordinator, Dr. Michael Giacopoulos. So there's a lot of information. Of course, you will hear about NSF fellowship a lot. You will get tired actually. But besides that, there are some other fellowships. This is called National Defense Science and Engineering Graduate Fellowships. Then we have Department of Energy Computational Science Graduate Fellowship. Then we have Link Foundation Fellowship. Actually, this is managed here at UCF IST and the simulation area. Then we have NASA Graduate Student Researcher Program. Then we have Ford Foundation Diversity Fellowship. We have Harriet Jenkins Pre-Doctoral Fellowship Program, again for NASA. Then Department of Defense has SMART Fellowship. And there's Anita Borg Fellowships. And then, FSGS Fellowships, and the National Academy of Sciences Fellowship. And then this is the website from UIC Chicago. They have lots of resources available there. And there are many other nice websites where they give you this information, IBM Minority Fellowships and so on. And all these things, Hertz Foundation, National Physical Science Consortium, and so on. So I think I'm done with this. So we still have a few minutes left. So do you guys have any questions, any comment from me? I went through quickly because we have quite a few other presentation and many of these will repeat. So who wants to start? Any questions, comment so far what we have talked about?
What's your opinion on the accelerated master's program?
Yeah, I think that's also good. So if you're not sure you want to go directly to PhD, then it's called BS plus MS program, that while you are undergraduate, you can join this program. And the courses you will take, the graduate courses you will take as undergraduate, they will count towards your master's also. So we have students who have done that. We have Brendan Clark, who is now going to be a PhD student. In the fall, I gave him a fellowship. So he's in that program and several other ones. So only thing is that there you won't get a support, because as we talk about, the graduate students are fully supported. So one is the fellowship, which is the most prestigious. Other is what's called GTA, that you become graduate teaching assistant, and you teach, you help with grading and maybe teach a lab section and so on. You work 20 hours per week, and you get a stipend and you get tuition, so you don't have to pay anything and you have living expenses. Other is what's called GRA, Graduate Research Assistantship. So you do research and that will count towards your PhD also, and you will be paid. So being undergraduate, you don't have much chance to get support, but that's possible to do that.
Hey, Dr. Shah, I got a comment.
Mm-hmm. Yeah.
So the accelerated BS to MS,
Mm-hmm.
I'm sorry, I have a really weird echo going on. So the BS to MS doesn't the classes that you take for the masters, they count towards your, because I'm in that program right now.
Mm-hmm.
They count towards your undergraduate class, like your graduation. And if you choose to pursue the master's degree, then those classes can count in your master's degree. But it doesn't mean that you're accepted into a master's degree or anything like that. It's just, it allows you to take more advanced classes in your undergraduate degree.
Mm-hmm. Yeah. So that's kind of the thing that you will save, like those 3 courses. If you take, then you will have 3 less courses to take.
Exactly.
So that's
I do have a question.
Mm-hmm.
That last presentation you made,
Mm-hmm.
Is that available offline?
All available. You will get everything.
Okay.
Whatever you talk about, you will get all PDFs. So it is all the links, all of this. So it's a lot of resource. So you can search for those, and for these fellowships, I think the main thing, there are many fellowships, and many of these fellowships actually not many people know, they don't apply. So if you apply to many of those, you'll have very big chance to get some fellowship.
Yeah, and just to be clear, that's not UCF specific, right?
No, it's anywhere. So actually you can, suppose you apply when you are at UCF, apply for fellowship, and then you decide to go some other school, you are free to take your fellowship with you. And if you apply from other school, you get a fellowship, you are welcome to come to UCF also. So it's pretty flexible.
Okay, thank you.
Another thing is, last thing, that you can do both. You can get a fellowship and be a GRA or GTA. So let's say you get 35,000 NSF fellowships and you get 25,000 GRA, and that's a lot of money, So you can, that's perfectly legal to do that. So that's also you want to keep in mind.
Dr. Shah?
Yeah.
Yeah, this is Li Tianwang.
Yeah.
I can add some comments about the question for the.
Yes, please.
Yeah.
So Dr. Li Chuan, he's the best person to answer about this, all these requirements on. So I may have misspoken. Yeah, please, Dr.
Yeah. And Dr. Shah understanding is correct. Okay.
Yeah.
So right now we allow the student to take 4 graduate courses, and the 4 courses can be used for both degree, BS and MS. So if you're already in the program and before graduation, and you should submit application for MS program. And so the basic requirement is, we need the GPA should be 3.0 or more. So that's almost same the requirement for the BS to get into the BS to MS program. Okay, so after you get into the BS to MS accelerated program, doesn't mean you directly will go to MS program. You have to apply MS program again. Yeah. So, but for the student not in UCF, you are not eligible for this program. But however, we allow the student, if you want to, apply for our PhD or master program, and you already took several graduate courses in your institute, and without master degree, we allow you to transfer up to 2 non-credit grad level credits to our master program or PhD program. Yeah, so that's a credit transfer.
Yeah, so I think that's we are making it easier for you guys to get into credit school, and there are lots of incentives, and this kind of workshop will help you to understand different details. And please feel free to ask questions and just enjoy. And you can turn on your video so that everybody can see you. And so now we are going to, in a couple of minutes, we'll start with Rachel's presentation, and then we will follow the schedule. Any last comment? We have 2 minutes left. Any more questions from me or Dr. Wang? So Robert, is everybody here? Who's missing? Some people are missing, right?
Yes, sir. We're just missing Lee Mao now. Well, and Zane, but he should have emailed you.
Zane is here. He's here.
Zane, you're here now. Excellent.
Okay.
Yes, so
And
just Lee Mao.
how about Leah? Is Leah there? Leah is there. Okay.
Lee is here. Yes, sir.
Good. So any other last question? Brian, you have a question? I'm just picking.
No, I think I'm good.
Okay. Tess, do you have any question? Anything?
No, everything is great so far.
Okay. Okay, very good. So yeah, Rachel, so you can go ahead, share the screen.
Okay. Okay, so hopefully you guys can hear me all right. Yeah, feel free to interrupt with questions or ask questions at the end. So I'm an NSF graduate research fellow here at UCF, and I'm going to be talking first a little bit about who I am, then a little bit about the NSF graduate fellowship program, which I'm a part of, sort of what the main takeaways are, what the application sort of looks like, and my personal advice for applying, and then how having the NSF graduate research fellowship has affected my PhD pathway. So I'm a 5th-year PhD student in optics at UCF. So I study telecommunications, and I specifically work on how do we increase the amount of information that we're transporting. So in terms that are relevant to undergrads, I like to say that I help the world watch more Netflix. So my bachelor's degree was in physics in New York. And after I graduate, I guess my long-term career goal is to work in research and development in industry. As you saw, I'm a 5th year, so I should be graduating soon, hopefully. So I recently accepted a job at MIT Lincoln Labs. So they're a federally funded research and development center. So they're funded by the federal government, but they're not run by the federal government. So you get some of the perks of good funding pathways. So like Lincoln Labs has 1,800 staff, and they get $1 billion in research grant funding per year. So I'm going to be working on advanced communication systems there. So like space communications for NASA and such, and underwater comm, all kinds of stuff. So a little bit about the graduate research fellowship program. So the NFSF graduate research fellowship covers 3 years of your stipend for your PhD. And at least right now, that stipend is at $34,000 a year. It sometimes changes to adjust for inflation. And then it also covers all of your tuition expenses wherever you go. And really important, and Dr. Shah sort of mentioned this, is that right now, 1 in 6 applications are successful. So if you do 34,000 times 3 plus whatever the tuition is times 3, that's around $150,000. And a 1 in 6 chance at $150,000 is pretty good. I think it's attractive to most undergrads. And then one of the things that stands out about the NSF fellowship is that it's very flexible. So NSF is funding this student, not the research. So if you're funded with the NSF fellowship, you could potentially change schools. You aren't tied to the research project that you wrote about in your essays, so you can switch your research topic. And also there's no obligations of things you have to do afterwards. So there's some fellowships where they might pay for your PhD, but then you would have to go work for a certain company or a certain national agency for a few years after graduation. And with the NSF Graduate Research Fellowship, you don't have to do anything after graduation. So as far as how often you can apply to the NSF Graduate Research Fellowship, you can apply once per year. And as an undergrad, you can apply as a senior and then until you start graduate school. So if you took a year off, say between undergrad and grad school, you could apply both as a senior in your undergrad program and also in that gap year. But as a graduate student, you can only apply once. At least when I applied, it was in your first or second year. I'm not sure if that's still true, but so anyways, the takeaway from this is that you should definitely apply as an undergrad, because then you have more chances to apply, because you can apply both as an undergrad and a grad student. And also when you apply, you receive feedback on your application. So here I have like an example of some of the feedback that you would receive. So it's not overwhelming, but you definitely get specific feedback on your application. So you could apply as an undergrad, get your feedback, update it based on the feedback, and then hopefully get it as a graduate student. Along with that, the application for the fellowship is very similar to what you're already going to be doing for graduate schools and other scholarships. So it's not that much extra work to do this fellowship on top of your graduate applications. So that application is composed of a 3-page personal statement about yourself and your career aspirations, and then a 2-page research statement proposing an idea in a research project. And then it's judged on intellectual merit and then broader impact. So that intellectual merit is sort of how sound is this idea? Is it an interesting idea? And then the broader impact is what would be the impact to the world of this research, and then also what would be the impact of yourself receiving the fellowship. So for like I said, there's 2 essays, a personal statement and then also a research statement. So for the personal statement, you're already submitting your transcripts to them, and so don't just restate your transcripts. That would probably make the judges pretty bored. And then also along with that, because they're looking through so many essays, try and frame your experiences in terms of how they have made you who you are and shaped your goals. So you want to tell a story, and a somewhat compelling story. You don't just want to sort of relist the points on your resume. And then also, because for this fellowship application, you're judged based on intellectual merit and broader impact, make sure to cover both of those in your personal statement. And you can be, and I think it's good advice, at least in my opinion, is be pretty explicit about what you think your intellectual merit and your broader impact are. You know, in my essay, I think I use those exact terms, and I think I even bolded statements that I thought were very important. Because like I said, they're going through a lot of these applications. And so the easier you can make it for the people who are reading these, the better. So then for the research statement, if you just Google NSF Graduate Research Fellowship essays, there's a few websites that have a lot. This one in particular, this Alex Hunter Lang, is really good because you can sort by topic. So you can see even that the different disciplines have slightly different essay styles. So sort of mimic the essay styles for your topic. And then use bolding and sectioning, even italics. I know that might seem a little bit weird, but in most of the winning essays that I've seen, that's one of the techniques that they use. And then be explicit. So, you know, call out exactly what the intellectual merit is and the broader impact. Don't sort of dance around the idea or use synonyms. It's definitely very important to find a professor or a mentor to help you refine this essay. You know, they have more experience with these things. And then also pretty important is you aren't required to actually perform this research. So, you know, hopefully it's a topic you're interested in, but if you aren't sure if the graduate program you're interested in could do this research, or, you know, you're not sure if everything would fall into place, you aren't required to do the research. So sort of come up with the idea, but you don't have to worry about the exact specifics of how to execute it, at least not at that point. So now just a little bit about what having the fellowship at UCF has meant for me. First off, it's a competitive stipend. I think it's, so at $34,000, it's more than the, I guess, base stipend that UCF offers. It offers students more freedom with their graduate programs and advisors. So another student mentioned this, but you'll be more attractive to graduate programs and advisors if you have this, because it usually means that you would basically be free to them because you're paying for your own stipend and paying for your own tuition. So you can be more selective in what program and what advisor you choose. And then along with that, it gives you more freedom, maybe with the research you do. So maybe the research you want to do doesn't currently have funding, but if you're a free student, or maybe the funding level is low, you can do a lot more with that. So usually, at least in my experience, advisors are more open to creative ideas if you come pre-funded. And then I would guess, so at UCF, and I would guess that other schools, some of them might do something similar, is so NSF says that they'll give the school $12,000 a year for tuition, but at UCF, our tuition is less than that. So UCF is happy to have NSF fellowship students. So as a perk, any money that's left over after you pay your tuition, they let you use for educational items. So if I do the math for my example, so over 3 years, NSF gave UCF $36,000. My tuition cost this much, so $13,000 over the course of 3 years. And so then the difference between the two is almost $23,000. And so you can use that money for conferences, for equipment, for laptops, desktops, things like that. For me, my original plan was to use a lot of this money towards conferences, and then COVID happened, and a lot of the conferences that I wanted to go to no longer happened. So, but it was really nice because it meant that I got to upgrade a lot of my work from home equipment, and my laptop and my desktop and my webcam and all of that. Then I'll just let me share one other thing. So I talked a little bit about that because you're already funded, it gives you a little bit more freedom. So if you were somebody who had some interest within their PhD program outside of just the traditional publishing papers. So maybe you're interested in entrepreneurship, or maybe you're interested in professional societies or community service or something like that. The graduate fellowship gives you a little bit more flexibility. So during my PhD, I was part of a professional society and we organized a number of conferences. So this is a picture of a career fair that we organized, a conference. This is a CEO giving a talk to a conference. This is the provost of Imperial in England watching that talk. You know, a bunch of people, and this was an international conference. So we had students from 16 countries come, and then there's a picture of just some of the students that attended. Oh, sorry. So
Thank you very much, Rachel. Great talk. So we still have 15 minutes or so. So who have questions? Please, you know, don't be shy. You know, this is your chance to ask any questions you have. Okay, who wants to start first?
Hey, Rachel. I'm John. Is this your 5th year? Is that what you said?
yeah,
So when will you be graduating?
the goal is October, end of October.
Now, did you consider the grow or the internship opportunities that they have, like this grip and grow? Or
Yeah, I looked into them and I guess they were sort of new enough that I couldn't find enough information online for me to really truly understand quite. Yeah.
because I know one of the GRF fellows here at UCF, she took advantage of the international one where she was able to go to Denmark and work there for 6 months, you know, part of her GRF fellowship.
Yeah.
Yeah, just to introduce John Weinchempel, as I say, he's Associate Dean of College of Graduate Studies, and actually he came back spending 2 years at NSF. He was working on this NRT program, which is another fellowship program which is given to university award, and hopefully we'll talk a little bit about that. So he has a lot of experience in those things. So he will give a talk, I think, next. So yeah, I mean, all the UCF students can feel free to communicate with Professor Weinchempel. And so do you guys have anybody else has a question? Michael Brown, you have some question, or Robert?
I don't really have a question so much as like
Yes.
a concern, I guess. Like when it comes to like graduate school, there seems to be like an importance of like having letters of recommendations from professors. And you know, just through a combination of circumstances, like I transferred to the school, and the semester I transferred to the school, like we went into like COVID mode. So so up to now, I have never really even physically met anybody from my school, and I'm like a senior going into this year, so I don't really have much time left. What would be a good approach in that situation?
Yeah, first is I will be glad to write letter for you. Okay, so you have one, so you need 2 more.
Okay, thank you.
So yeah, I think that, so you still have some time, but you must have taken courses online, right, with some professors. So
Yes.
the subject, you know, you can always, you know, contact them through email, and hopefully in the fall it'll be face to face. You can meet up with them. And have you done any like internship or anything, or any?
No, and not at least in like
Mhm.
computer science,
Yeah.
because like I said, like I only got into like the program really like about last year,
Hmm. Yeah.
and there wasn't much there wasn't really much you could do.
Yeah. But you can start now, right? So you have at least 1 year. So you can, start thinking about, what courses you will take, and then get interested in those professors, and you'll get letters from here, um, and maybe get involved in like tutoring or helping, your fellow students who are junior. That also helps. You can mention that, as I said. And the best thing will be if you can get a paper, if you get a paper with Jyoti, that will be the most, that will help you a lot. Even Jyoti can write a letter for you, graduate student. So I think it's just be aware that you have to prepare, and 1 year you can get hold of, some people write letter for you. And that does have to be more specific, where many times, some people like very generic letters. They won't help much. So you
Yeah.
want to target that, well, you take the particular course in the fall and you build relationship with that professor, go to office hours, ask questions, do very well in homework, and even show interest that you want to do some research or independent study. So those kind of things, make you unique compared to everybody else.
Dr. Shah.
Yeah.
I have some comments on that.
Yes, please.
Something I've done just
Mhm.
because I've been planning this out for a long time.
Mhm.
I actually went around to professors and research clusters of the college and was asking, do you need somebody that that can, do some little stuff here and there? And you'd be surprised how welcoming they'll be. And even if it's not an area that you're specifically focused in, you can still learn about the research process from them, and be able to have people to talk to about these things. So the biggest thing is to get out and to talk to people.
Yeah, I think that's a very good point. I mean, I remember, Michael, you also came to me, right? So you took an initiative. You sent me.
Yes, sir.
I made an appointment with you, meeting. I gave you advice.
Yep.
You should follow that, and yeah. So that's a very good point, that you just have to start the process. It's the same thing that the earlier presentation from Enrique, that you have to go to the fellowship office. There they have a lot of information. Then there's a special program for minorities. There's a whole program called McNair. There's a very nice article in Pegasus magazine this time. They talk about how student didn't have any clue. She just took a course in math, and this math professor at UCF walked her to the fellowship office, and she didn't know, what PhD is about, and she applied for a PhD, got in some top university, and so there are lots of stories. I think all these things are possible. You just have to make an effort, and there are lots of people will be willing to help you. Okay, any other comment, question? Leah, you want to ask some question?
No, I'm all good here for now.
Okay. How about Chu Chen? You are doing so well in research, so you should definitely go for grade school now. Dr. Mitchell Hill from statistics will write letter for you. I can write letter for you. So there are 2 letters right there. So do you have any question?
No, I don't think so. I don't go to UCF, but Dr. Hill says that I can continue working on this project next semester over Zoom.
Yeah, I mean, you don't have to get letter. If you go to UCF, you have to get letters from UCF. You can get letters from anybody. You can go to any school. So it's not necessarily that, UCF professor can write letters for you. Even you are from Arizona, right? So, and you can apply to any other school. So that's not a problem. Okay. So we can. So John, maybe you can share. So thank you, Rachel. Really appreciate it. So you won't be here next year. You are graduating next year. Is that right? Or
Yeah.
yeah. Okay. So well, good luck. And so your advisor is
Dr. Lee.
Dr. Lee, Yifeng Lee. Okay, I see. Good.
Yep.
Okay.
Exactly.
Okay. Thank you very much. Good luck.
No problem.
Really appreciate it. Yeah. So now next presentation is from Professor John Wine-Champel, a good friend of mine, and he has a lot of information, very, very relevant. He has a lot of experience because he's in College of Graduate Studies. So every university has its college which manages the admission, the fellowships, and degree certification, all things related to graduate studies, master's and PhD. And then on the top of it, he actually just came back last month from National Science Foundation, where he spent 2 years. So he has a lot of information about both. And we are very thankful to him that he is able to make this presentation. So please feel free to ask him lots of questions. And so John, it's all yours now. Thank you.
All right. The screen's good, Mubarak? Sharing it okay?
Yeah, we can see it. Yeah.
Perfect. Hey, yeah, feel free to interrupt me as I'm going along. I need to leave at 3 sharp, but I think there'll be a little time at the end for questions, but feel free to interrupt. So as Mubarak said, we go pretty far back, and he actually was my boss for a year while I was associate dean, who was the dean of the College of Graduate Studies for a bit. As he mentioned, I just got back from NSF. I worked on one program called the NRT, which stands for the NSF Research Traineeship Program, which is an opportunity to work as cohorts of students focusing on a variety of STEM disciplines, interdisciplinary areas that kind of represent cutting edge areas. But I also work side by side with the Graduate Research Fellowship Program team as well. And so I work with them also, and I'm very familiar with the program. I serve as Associate Dean here at UCF, and one of my responsibilities is called the GRFP Official Coordinator, or Coordinating Official here at UCF. So as Rachel would make requests to spend some of her money, she would come to me and I'd say, yeah, go ahead, spend it. And it really is a pretty amazing program. I'll talk a little bit about that as well and try not to be too redundant with what was presented before. So if we think about, what are we doing, if you want to go to graduate school, and in particular, in some of the areas that you have expertise in, you really go to universities and you should be receiving almost full funding from these universities. And there are a variety of sources out there that can help fund you. There are teaching assistantships, research assistantships, and fellowships. And fellowships represent those more prestigious awards, as Rachel has spoken about. Typically, when you receive a research assistantship or a fellowship, you'll get a stipend and you'll get some tuition assistance, and it provides networking opportunities for you. And because graduate students are often sought after to do STEM-related research, that's largely a focus of some of these fellowships. STEM, if you don't know, that's science, technology, engineering, and mathematics. What I found out at NSF up until like 2002, they didn't use that acronym. They used something called SMET. So they kind of inverted some of the letters. And I think it took someone very clever to say STEM sounds better than SMET. What you want to consider when you're applying for these fellowships is really do your homework. You really do want to apply early and think about it. You do have up to 2 opportunities if you're applying for the GRFP fellowship. So, here you are as undergraduates, you have the time to maybe think about that and maybe apply in your senior year or during a gap year or once during your graduate year at your graduate institution. Some of these fellowships that you'll find are internal to the graduate institutions that you apply to. UCF has a number of fellowships that we give to meritorious graduate students. And then we certainly do encourage you to apply for external fellowships like the GRFP. And I think the last thing that Rachel said was apply. I mean, that's how you get them, you apply. But there are a lot of resources at your institutions that can often help you craft a good, solid proposal or application for these fellowships. And so you want to ensure that you take advantage of all the resources that are available to you. So in terms of the GRFP, Rachel maybe was a little bit shy. I don't think I heard this from any of the presentations, but many former GRF or graduate fellows have gone on to become Nobel laureates, members of the National Academy of Sciences, Engineering, and Medicine. You probably know the names of a few of NSF GRFP alums. One includes Sergey Brin, one of the co-founders of Google. Another one you maybe know is Stephen Levitz. He is an economist who is one of the podcasters of Freakonomics and one of the co-authors of the book called Freakonomics. Stephen Chu, who was the Secretary of Energy in the Obama administration. He was also a GRFP, but there are multiple people who were involved in discovering the Higgs boson particle, and they're covering the whole gamut of science and engineering. And as Rachel said, this is all kind of old news because she kind of went through it. You get up to $46,000 a year. Some of that's dedicated to your stipend, and some of that's covering the cost of education. Most institutions also produce a topper, which maybe adds to that, because this is something that we really encourage students to seek. And if you get it, it's a little bit of like a golden ticket that gives you an opportunity to kickstart your graduate career. In addition to the GRFP, if you were to get the GRFP, there are other opportunities for you. One is called GROW, which is an opportunity to study abroad in a variety of countries in some research labs there. And a new one, this was altered recently. It used to be called GRIP, but now it's called Intern, which enables you to work in a non-academic research lab. So I could be at any government agency or nonprofit or industry. And with both the GROW and the Intern, you can take 6 months off from your GRF award, and you'll get paid at the same rate for that half a year. So $17,000 for half a year to take it with you at some places. The GRFP award, as Rachel mentioned, was like 1 out of 6. And they just, I believe, upped the number of awardees from 2,000 to 2,500 a year. So that return on investment is actually among the highest at NSF, meaning that the rate of competition, although you do need to be exceptional in order to get the award, but the award rate is higher than most NSF programs. Some of the things to consider, you have to be a US citizen, national or a permanent resident in order to be GRF eligible, and you have to be a senior undergrad or an early career, which means up to your the second October, typically the second fall October, as a graduate student. You need to be pursuing a research-based degree. That means it will culminate in a thesis or a dissertation. So it's for these research-based degrees. And you have to be a full-time student in pretty much any STEM field of study. NSF is divided into 6 directorates, and the directorates cover, let's see if I can remember, biology. That was basically my directorate in terms of research. There's the EHR directorate. Oh, actually, there's 7. EHR would be the education research, or education and human resources. There's the MPS, the math and physical science, which includes chemistry. The one that most likely Mubarak gets funded is SCISE, which is the computer information sciences and engineering. There's an engineering, there's geo. There's also, well, physics and astronomy is under MPS, and social behavioral and economics is another directorate. But so if you can think anything that's science and engineering, there really is a location at NSF for it. However, the one caveat is that it doesn't relate to clinical medical research, and that would fall into the domain of the National Institutes of Health. Now, given these wide range of GRF fields of study, there also is kind of a little bit, although this led to a little bit of controversy in 2020, areas of emphasis, and they slightly modified their solicitation, but still this is in the solicitation, just maybe not as prominent. 3 areas of emphasis that maybe relates to you, I think certainly 2 of the 3 do. Artificial intelligence, computationally intensive research, and quantum information science. So these are funding avenues that the federal government identified as important to the future of the security and economics of the United States. And so those represent areas of emphases that you will see when you look at the solicitation. I think pretty much every component of the solicitation identifies these 3 areas. So like biology will have these 3, chemistry will have these 3, physics will have these 3, etc. The beauty of the GRFP is that it is flexible. As I said, you have a golden ticket. Often what happens is that students flock, they get their GRFP, and then almost any university will want you. And you do have some variety or some selection capability. You can choose where you want to apply this particular, where you want to get your degree and apply your fellowship, you know, as long as there are the appropriate faculty to support your research. There is no service requirement. You get three years of the award that you can spend out over 5 years, so you can take years off and work on other fellowships or other research assistantships, or you could do an internship along that. And as Rachel said, at UCF, we allow you pretty much to keep your cost of education allowance. And what students usually use it for is to travel to conferences or buying little bits of equipment that they can afford off of those $12,000 a year. As mentioned before, you know, there are some components that you'll want to consider, and you want to be very intentional with everything. You really have to think it through. Even though the award rate is pretty high, you really do need to nail it. There is no doubt you do, and there are resources out there that help you in terms of crafting it, as well as resources at your institutions, including UCF. UCF last year had I think 15 GRF awardees, and I think 14 of them were undergraduates. So I'm going to expand on what Rachel spoke about in terms of the 2 NSF merit review criteria. One is intellectual merit, the other is broader impact. And so with every NSF proposal, these are common review criteria with them. The intellectual merit is really the perception that you and what you propose to do will advance knowledge. So, you will propose something, you may or may not pursue it, but at least you demonstrate that you would have the capability to follow that particular path, and that path would somehow move the needle of science and engineering. And so that's the intellectual merit component. The broader impact component is really, what kind of societal impact would that kind of research have? And some of that may also relate to your background as well. If you're doing something that's unusual, you may be providing a role model for future students that are going down a particular avenue. And so, you kind of think about these things when you come up with your application. How am I advancing science and engineering? And how is this somehow helpful to the broader society? And so it's really important that you clearly explain that to all the reviewers. With the letters, they follow this process where they ask you to suggest up to 5 reviewers or reference writers. And the reference letters you then rank. So you kind of say, okay, this would be my first reviewer, my second reviewer, third reviewer, a reference letter. And your top 3 are chosen just in case one of them doesn't submit. That can happen, but it's really your responsibility to make sure that you choose reference writers who are going to be diligent and they know you sufficiently well so they can provide a good background on not just you as a potential future science or engineer, graduate student, but also with what you've done, they're familiar with you, and also your project. So if they're able to also speak to your project, that's also valuable. These letters, it's often good to have multiple iterations, and you want to choose faculty members who can also follow instructions, because it's important that they craft very good letters. In terms of deadlines, the GRF application should open up very soon, but typically what happens is people wait till the last week to submit, so that's late October. Because this is actually the longest running program at NSF and consistently among the largest NSF programs, we actually outsource some of the review process and responsibility associated with it. We typically get 14 to 15,000 applicants for this, and up to 250 or 2,500 awards. The announcements come out. You would submit, late October is when everything's due. The announcement comes out usually late March or early April. They'll release it to all the universities and all the people that have submitted. And for those of you that are lucky enough to get the award, you have a window of about a month to accept the fellowship. You aren't able to postpone it. But so usually you have a month to do that. If you don't get it, they also have what's called honorable mentions, which is certainly notable if you get an honorable mention, but sadly there's no money involved with that. So you want to start early. Read the solicitation and the frequently asked questions very carefully, and you want to follow all directions. Rely on the expertise of others. You will want to, at some level, it's going to be a brag. You have to describe, what you bring to the table. What has been your outstanding accomplishments that you have done thus far? And as you go through this, it will take multiple times to review it. You also want to make sure that it's not filled with jargon so that a broad audience can understand the importance of what you propose out there. At some levels, though, the GRF is really evaluating your potential to be a strong scientist and engineer. So you want to keep that in mind. Even though Rachel said maybe the research isn't that critical, you still want to make sure that your research is going to be viable and it is obviously going to push the envelope out there. So you have to demonstrate your ability to understand what the current state of knowledge is in the literature out there, and you want to be able to advance that, even though you may not end up pursuing that particular research avenue as part of your graduate career. Focus on those merit review criteria. Certainly make sure your reference writers are familiar with what you're trying to accomplish with this. Now, associated with the GRFP, as I mentioned to Rachel, are these two opportunities. One's called GROW, the other one's called Intern. The GROW Fellows provide an opportunity for international experiences beyond the GRF program. So, you can think about it, this as being an additional ability to develop yourself professionally and scientifically, in a broader audience with an international group. And there are about maybe 20 or so GROW partner countries that are involved with this. The student who I mentioned from UCF, she went to Denmark associated with her GRFP using, and she studied migratory paths of marine organisms, and they had some expertise at Denmark that she was able to learn from. So this is kind of a neat opportunity in addition to the GRFP. The other one is this intern program, and this relates more, this is a domestic program where there are opportunities for you to pursue an internship with non-academic institutions. So you can take a break up to 6 months from your GRFP program, and you can get paid at the same rate as you would with the GRFP, but you can work in a government lab or industry, and we've had, I've helped review some of these with my program with the NRT, but also with the GRF. We have students who will go to local, state, and federal labs like Los Alamos or Sandia, as well as opportunities to work with industry as well. So just another method to really help broaden your experience, because we recognize that actually it's a fraction of all scientists and engineers, especially in the field that you're learning about with your REU, continue on in an academic career. And Mubarak kind of showed some of the lucrative paths that some of his students and colleagues were able to follow outside of academia. And this intern program gives you an opportunity to explore some of those paths as well. So there are a lot of resources, and Mubarak will have these, so you can look at these afterwards and he can distribute them to you. Really, there are many in addition to this. There are a group of students, successful fellowship writers that have banded together and provided hints that you can use that perhaps will help you develop a stronger application. Now, there are other applications out there, other federal agencies and industries out there that you might want to look at. One is with Department of Energy. They have a computational science graduate fellowship. You see the yearly stipend is a little bit above the GRF. I'm not sure if everything is the same. It only has an annual travel allowance of $1,000. But you see there are some different requirements. This is a much smaller in terms of number of students that are involved, but maybe it's more focused on some of your areas of interest than the GRF. This is available to undergraduate seniors. So it's, those new graduate students that are just getting started, also it can be eligible for them. And you can see that there are other, related areas that it may also beyond computational science. It may also look at the interface of computer science and material science, mechanical engineering, physics, etc. Something that you may want to consider depending, where you want to go. You are able to apply for this fellowship simultaneously as you would apply to the GRFP. So you may want to consider, applying to more than one fellowship. And there are a list of other ones. I think Mubarak mentioned the Link, Ford Foundation. There's the Google Scholarship Program, the National Defense one, and then one that I earned back when I was a student, and one of my grad students just got last year is a NASA graduate fellowship. He got something called the Finesse Fellowships, which deals with Earth and space science technology, which is very comparable to the GRFP. 3 years at $34K. Now, all institutions typically have their own in-house fellowships as well. UCF has a number of these. One of my goals is to augment the value of these fellowships this year, to make them actually somewhat on par with the GRF or very close to it. And what you'll want to do typically is, if you apply to the universities, in some cases they'll ask you whether or not you're interested in the fellowship. Sometimes you're automatically going to be considered for a fellowship. And these are typically based on your grades and GRE scores, as well as your program often that you're applying to often will nominate you for these particular fellowships. And so these are things to consider as well. They come with a stipend, usually come with a full tuition waiver, and then maybe some other expectations out of this. There are resources that you can find online that will help you identify additional funding avenues. Pivot is one that UCF has. I think we pay for that. Grapes is one that comes out of, I believe it's UCLA, which is free for you to use. These are basically search engines that focus on funding resources, and you can kind of narrow your filters, your search to graduate STEM fellowships, and a variety of these will show up. And you will really find that there are many sources of funding out there to help support your graduate career. You have to, though, figure out which one's the most relevant for you, and what their particular requirements are, and whether or not you're eligible for those particular funding avenues. So you want to start early to think about that and follow through on that. If you are at UCF, the Pivot, I believe, is offered through the Office of Research, and if you're working with a faculty member, they may be able to help you craft that search. So I believe that is all I have. Feel free to contact the UCF Grad Fellowship Office, or contact me if you have any questions related to graduate research fellowships or graduate school in general. I've been in my current position about 6 or 7 years, and I was just in the Division of Graduate Education at NSF, so I'm aware of some of the efforts that are going on in NSF. All right, well, thank you very much for your time, and I'm open for any questions if you have.
Yeah, thank you very much, John. This was very nice. Covers all these things detailed. Yeah, so who has any question about the UCF? As you know, that UCF has own fellowships, and there are then NSF fellowships, and then other agencies. And of course, I will send you the copy of all these presentations. So John, the number of fellowships, like the funding, you said that's the largest program within NSF. So are they thinking about increasing this, budget?
Yeah, absolutely. What's going on is, it is a line item in the federal budget every year. And so, in terms of numbers, they're interested in increasing. And when I spoke to some of the what are called program directors, there are 3 program directors who are in charge of the GRF program. And I kind of let them know that the $34K, even though by some metrics that's a lucrative award, that's becoming less and less so. So I imagine it won't be too far down the road where they bump that up a little bit more also, as, cost of housing has gone up and cost of living in some areas has gone up. There are, I think, 400 GRF fellows at MIT. And so, the cost of living in Cambridge is pretty high. And so, they represent a little bit of a force that perhaps will help move that a little bit.
Yeah. So number of fellowship there must be increasing also as the population grows.
Yeah. So I think it was last year to this year went from 2,000 to 2,500. And so that's nice also. And so it really is a good place to apply. As 1 out of 6 is a really good funding rate. My program at Nfsf was more like 1 out of 14. So, I think it's something to consider.
So what percentage is the NRT, like the total number of these fellowships? That's pretty small compared to this GRF, is right?
Yeah. So it's the NRT. We have 120 programs, and that will fund up to about 25 students per. So it's actually not too different, in terms of size. But really, most graduate students, Mubarak, are funded off of research grants, not fellowships or traineeships. Although there is a big move to increase the number of traineeships, because it seems as though they have been a success in terms of trying to find novel areas of research in science and engineering and really ensure that students are well trained in those new areas.
Okay, so last chance, any question? Because John,
I got a question, Dr. Shah.
Yes, please, go ahead.
So I've been doing research on how to write these papers that we've been talking about. And so once we have something completed and written, and we want someone that's knowledgeable to review it, because I know you mentioned something about this, but who specifically would be the best, who would I take it to? What's the best way to go about making sure I have a high quality document that I can submit?
You mean research paper or your application for fellowship?
Application for because naturally I want it to look and present very well so that it represents me very well.
That's right. Yeah. So I think one is that, and maybe John can say, why don't you answer that?
Yeah.
John?
So Michael, there's often, are you from UCF or are you from elsewhere?
Yeah, he's from UCF.
Okay.
Yes.
At UCF, there's something called the Office of Prestigious Awards.
Yes, I've been there.
And so, there's a potential group to review that there. Also, there's a small group that we've actually started with Michael Alderando Jeffries. And what we're trying to do is kind of create some peer mentoring as well as faculty development that will help these students, write or craft good applications. So we've started a 0 credit hour course that's available, I believe, in the fall, and we can get the information for you about that. So 0 credit means, you don't have to pay for it, but it's an opportunity to, talk about developing some of these applications and reviewing some of these applications. But I think your first go-to should be your peers, people that perhaps are in your REU, or people that have some comparable expertise. And then I would look at, you have a whole suite of professors in computer science, if you're focusing on that area, that may be able to help you, or graduate students or postdocs. I mean, so you have a group of kind of part of the science and engineering ecosystem for every program that can help you develop these. And it really is, a process that you want to look at and make sure you get a lot of feedback from it. And then a broader audience, sometimes it's good to have, non-specialists read it as well. So you might, some of your relatives perhaps that don't have the expertise, but can read it critically and ask those questions that you may not have thought of, because even though you'll be, as part of the review process, you'll be somewhat lumped or binned into some areas that potentially relates to what you propose to your research in. So if you're coming out of this REU, you'd probably have a size bin, computer information, science and engineering kind of bin there. But that doesn't mean that everybody has that same background that you do. And so it's good to make sure there's kind of a broad or ability that a lay audience can understand the importance of what you're trying to accomplish.
Okay, thank you so much.
Okay, very good. So I think its time is up now.
Yep, I need to run. All right, thank you very much, everybody. Best of luck.
Yeah, thank you, John. Okay, very good. So now the next one is Angelina Levy. Again, she's the first year. You can go ahead, share the screen. Thank you very much again for agreeing to give this presentation. This is a very, very good.
Of course, I'm excited to chat about it.
Yes, yes.
All right, well, hello everyone. As mentioned, my name is Angela. Oh, why is this not? There we go. My name is Angelina Levy. A little bit about me before I start talking about my NSF application is I'm actually over in the psychology department, so a little bit different from computer science, computer vision. I'm a third year clinical psychology PhD student. I also completed my undergraduate degree at UCF. While I was at UCF, I did an undergraduate thesis. I think they call it something else now, and I also studied psychology and statistics. So my application might probably look a little bit different than how yours might look, but there's still going to be a lot of the same elements. I'm currently in the real-time lab where I am currently working on developing a new measure of responsible drinking identity. I also have a dog named Bella, and that's just a little fun just to break up the day. Yeah, and feel free, if y'all have any questions, feel free to just jump in whenever you want, okay? I also had a little about the NSF GRP, but I think y'all at this point hopefully know a little bit about it since a lot have been talked about the NSF grant, pretty much a lot today. So again, why should you apply? Money is a nice thing, and I popped it at the end, but we're talking about increasing it, which is very exciting. But it is considered a prestigious award. There's about only 16% acceptance rate. They also give money for tuition and fees, but the leftover could be used for other stuff. So this past year, I was able to use it for my research. I fully funded my master's thesis with this, and I got myself an iPad, which is very cool to do. You don't have to be a TA, which is very exciting. In graduate school, I don't know, I think REU is usually for undergraduates, if I'm correct. For graduate school, at least in my program, they offer free tuition. However, the trade-off is to be a TA. And when you TA, you just kind of grade a lot of papers and you work up to 20 hours a week. The best part about this is you don't have to do it because you're fully funding yourself to go to graduate school. And what's nice is you could use it at your choice. Hopefully kind of already talked about how to apply. So I'm just gonna go slightly past that. One thing that I want to talk about, just because I am in the social sciences, this past year, I'm not sure about the upcoming year, but they really focused on artificial intelligence, quantum information science, and computationally intensive research. Unfortunately, it was not my social sciences. But I think since y'all are more computer science, hopefully this won't apply to you. But if you're more into social sciences, that's something definitely to be aware that's going to be a little bit more challenging. Should you apply? Yes. And I kind of wrote this. Like I said, I'm a training to be a clinical psychologist, very into imposter syndrome. Y'all are all here. Y'all are in an REU. Y'all have the skills and ability to have a really strong NSF application. So yes, you should apply. I included this meme because I think it's a really funny meme, but I think it's really accurate about how I notice a lot of my peers kind of talking about, oh, should I apply for the NSF grant? Oh, I don't think I'm good enough. I didn't do enough research. I didn't do this. I didn't do that. But you did a lot of other things, right? And I think that's really important to talk about. Talk about all the really cool things that you've done in your life. That's what I did. So two of the really important things, the application that they're looking at is intellectual merit and broader impacts. So intellectual merit is kind of talking about the potential to advance knowledge. Not saying how smart you are, but how you're able to advance knowledge in your own field. Broader impacts is how does what your application and you as a person benefit society? One thing that was really important, that advice I got when I was first applying for the NSF, was someone told me, you have all the skills, you're in a PhD program, you got to research. They want to know if you're a good person, if you're a person that's worth giving this award to, because Nfsf is attaching their name to that. And that's why it's something really important, especially with the NSF. You want to have your research and just you showcase that, yeah, my research is really important. We could really help society. So kind of talking about my application. So I have it written here. I believe this is recorded, so hopefully y'all be able to read and pause, or if you want it, I have my email and I'm more than happy to send this to you. So a few things I want to point out. I noticed that someone had a question previously about formatting and stuff. So as you can see, I did centered font and I did no indentations because it was a very strict word count, not word count, but page count. And some other things I did that you might notice is I really bolded the things that I really wanted to be showcased and things that are really important to me. So this is my personal statement. And as you can see, I kind of broke it up from my background. So who am I as a person? My research experiences and intellectual merit. What did I do that was really cool? And then I ended up with broader impacts. What did I do that was really cool, that really helps society? And then my future goals. What do I want to do if I have an NSF grant or fellowship? So this is how I kind of wrote it. And I wrote it like a story. Like I said, I have a background in clinical psychology. So this is kind of how I write in general. However, you want this, they don't know you. The people who are reading your application, they really don't know who you are. You want to tell them who you are and how cool you are as a person. And you really want to explain that through your words. As you can see, if you kind of read through it, I kind of make some jokes. I was talking about making lemonade as a child, and I did not really do really great at it. And my science experiment of looking at people was really not great, but kind of talking about it and showing your personality. As you can probably see, I'm a very bubbly, talkative person, but you want that to showcase through your words. I noticed there's some folks that I try to help out, but and read their personal statements this past year that were applying. I know sometimes that they were a little bit more, I guess, too robotic and didn't really showcase their personality. It was not as memorable for some of the people viewing it. Again, this is just my own personal advice, so give or take, but that's just some of the things. And I really like how I phrased it. Talk about my undergraduate, I talk about my first year in graduate school, because by the time I was applying, it was October 2019, so I just started graduate school. Yeah. And so here's my research plan. So since I know this is RU, I can focus a little bit more on a research statement. So my research was so there's a theory called Deviant regulation theory. And basically it's a theory that predicts how someone is going to act based on the social norms of a situation. Basically, if you either want to stand out, standing out looks really good, or you want to fit into a crowd, and standing out makes you look bad. I usually have a focus in alcohol use. However, for the NSF grant, you cannot do any intervention research. And I've done a lot of intervention research just because of clinical psychology. However, what this specific one was arguing was kind of looking at the mechanisms why this theory works. A lot of clinical psychologists kind of look at the behavioral elements of this theory. However, I was really interested in why is that the case, okay? And I kind of proposed that identity changes might actually be the reason why people change. Hence why my new measure for my master's thesis is to create a measure of responsible drinking identity so I could actually apply the research I proposed for my NSF fellowship to look at this, because we need a new measure because it currently doesn't exist in clinical psych. As you can see, this one is only 2 pages, which is really, really tiny and was really hard to kind of put everything together, especially because deviant regulation theory, or DRT, is a really complicated and convoluted type of theory that has a lot of ins and outs. So what I did is I really focused a really quick introduction and rationale. So kind of talking about what is going on, why is my research important? Why has my research been more important than the other person that you're about to read? And then I really focused on my theory that I was doing because, again, I was trying to focus on more theoretical, basic research. And then talk about my aim. What do I want to get out of this? What is my goal of my research? Then I also included my hypotheses. Then I included what is going to happen with my, what do I propose for my study? And I also did some a priori power analysis and included that, kind of really talk about EMA, which is something, ecological momentary assessments, which is something my lab does. And also really focusing, again, having a section for intellectual merit and broader impact. I noticed that it's something a lot of successful applications have inside, like really directly, like, hey, since you're grading me on this, here you go, read it, it's nice and easy. It's bolded and underlined right here. Again, I bolded a lot of my really important things that I wanted to say. Everything is centered, no indentations, just because I wanted to be mindful of the spacing. Also, you might notice here that my references is very kind of different. Usually I do APA style being in psychology. However, I kind of made my own style, I guess, just to fit this. And because I wanted to include my citations. So it was very thing. As you notice, I did also cite myself and I bolded it because I wanted to showcase that, yeah, look at this cool stuff that I've done, and it's very relevant to actually this project that I'm proposing. You might also notice that I have a few charts in here. I have a theoretical framework of deviant regulation theory, and I also have my hypotheses. This is something that I was keeping going back and forth with my advisor. I guess I should have introduced, is Dr. Robert Dvorak over in the clinical psychology department. And we kept on going back and forth because we were worried about the spacing and stuff. However, we both decided that maybe having some figures and graphs, as well, I guess in my case, it's figures, really kind of helps give color to it. It kind of looks pretty. And it also kind of helps the reader understand something that I'm talking about. Like I said, it was a very kind of convoluted, complicated theory. So it's having a nice little graph to kind of showcase, for example, if you and let's talk about messaging. So you get a nice positive message about how cool people are who do this behavior. And you get positive, but they have high norms. Something negative about how people who don't do this thing would be really salient. Whereas for low norms, the opposite, which is my proposal. So this is something, so these are my reviews and why, I guess per se, how I got it. So I got this individual very good, very good. Some things that I guess they had, so for the first reviewer, they were concerned about my characterization and measurement in the project, which is also why I'm working on my master's thesis, creating a new measure of personal identity change or identity component in general. And again, since this is recorded, you feel free to read through this whenever you can. Some other things that I really think is really important to point out was the ability to engage in research, being able to supervise undergraduates. Something I didn't mention is when I was an undergrad, I was a laboratory manager for the lab, for real-time lab, which is the lab I'm still in. Love it so much, I never left. I was so kind of talking about that and how does my past really help showcase my future? Kind of talking about some of the things I did, some of the statistics, like multi-level modeling, and kind of showcasing that. So this individual kind of talking about the, which is good, but that's okay because I got excellent for broader impacts, kind of talking about how am I able to do so. They were talking about changing alcohol use in college students, which is traditionally what I do in my lab, and kind of really showcasing that it's really important to talk about it. And then also kind of talking about one thing I like here is they talk about unusual and valuable perspective. A little thing about me is I was diagnosed with multiple sclerosis when I was in high school. So that was something driving that was really prevalent throughout my whole paper, my whole personal statement, kind of having two streams. One stream being my life with multiple sclerosis, how that affects me as an academic, and then also my research. And kind of having those two strings continue throughout the whole paper, really showcasing, okay, I have what it takes. I have a really unique experience. Now, a lot of people with disabilities go into higher education. I have a unique perspective as being a scientist with a disability and really showcasing on what makes me unique as a person. So one thing that they were worried about is because I have the same general topic and worked in the same lab I did in undergraduate and in grad school. Some people might have different opinions about that. I guess what they call is academic incest is what I've been told, but that's okay. But the previous individual really liked that. So again, it's kind of subjective in these views. This last reviewer was talking about high course grades, really productive research to date. I think at this point I had 5 published publications and 5 presentations at conferences, which again, you just kind of want to showcase what you do have already. And this individual really liked that I was applying on my previous work, whereas the previous reviewer didn't really care for that. So that's something really important to talk about. And kind of really talk about, they did not think I had intended statistical analysis. There is not enough room, but again, everyone has their own cup of tea of what they want in an application versus what they don't want. And talking about public health and behavior change, and talking about ability to mentor, which is something really important to me. And talking about ability to be a leader, not if you are currently a leader or able to be a strong researcher, your ability and potential to be, and that's something really important to talk about. So some of my advice. So I included this link in this PowerPoint, again, since it's being recorded, and y'all could feel free to email me. I have my email at the end. Mallory Ladd has a fantastic blog talking about the NSF, and they actually have, like, I think maybe 30 previous winners essays, which is really great. A lot of them also include their email. And also, y'all are here. Y'all are engaged in this conversation, which also is really helping you have a stronger application. They also, UCF, if you're at UCF, they also have the University Writing Center. You can talk to faculty mentors, your friends. Office of Prestigious Awards are all really good ideas. To be a strong applicant, I think is being passionate and self-motivated to be your best self is really the most important thing. Showcasing how cool you are. You're here in an RU. I already know y'all have the ability to be a strong applicant. You just want to showcase how cool you are. And I'm using the word cool because I think computer vision is cool. And I want you to showcase how passionate you are about your work. And that makes you a really strong applicant. One thing that I think is also really important to talk about when you talk about the GRFP is what happens if you don't get it. I have a little meme from Game of Thrones. What we say to imposter syndrome, not today. It's not a reflection of your intellectual or your worth. if you don't get it, is sometimes it's extremely competitive. Like I mentioned, only 16% of the population will get it. And as you see in some of the scoring, it's kind of subjective sometimes. You even see some of the reviewers, one reviewer saying, oh, awesome, they're continuing their work that they did in undergrad, versus, oh, they shouldn't do that. They should expand their horizon, broaden their horizon. So it's kind of challenging. I know sometimes I went to UCF, which is my undergrad. UCF is not like MIT or Stanford or one of these big name schools. And those schools are notoriously more likely to get GRFPs. So that's another thing, not to discourage you, but just something that it's important to talk about if you don't get it, and that it's okay. And it's also really good experience being able to apply to fellowships. And you can apply that knowledge to other things, like at 32, that's something of interest with, well, I guess that's more NIH. So maybe y'all won't apply for NIH stuff, but other applications, and you can really apply those skills. So this is my email, and I'm going to stop sharing my screen, and I will also put my email in the chat. And yeah, feel free to ask any questions y'all have right now.
Okay, Angelina, very nice, great presentation. I think this is the first time we have seen the actual application and all the sections and also the reviews. That was really useful. That really give impression, you know, how you go through the process and what you expect. That's very good. Yeah, so who else have questions? Please start, you know, it's a very good chance for you. And of course, Angelina is also from UCF. Please don't be shy. Ethan, you have a question? Or?
Just taking some notes.
No worries.
So Angelina, you are third year, you said? Third year PhD?
Yeah, so I'm a third year of my PhD program. I got the NSF so it started next year. So this is going to be the start of my second year on the fellowship.
So it will start this fall, or it already started last fall?
I started the fellowship last fall. I started my graduate school program 2 falls before,
Okay,
so in 2019.
I see. So you have a chance. You can apply within the first year of your. Either you apply before you start graduate school, or you apply during the first year, right?
That's correct. And sorry.
This was the first time you apply, or you applied before also?
Yeah, so it's the first time I applied. I actually never heard of this fellowship until my advisor was talking about it and thought I had a good chance. But one thing that's kind of nice is if you are a post-bac or you're currently a senior, you can actually apply it an infinite amount of times, technically. However, when you're a graduate student, you can only apply once. So that's something important to think about.
I see. And who's your advisor in psychology?
Dr. Robert Dvorak.
I see. Okay. Okay, very good. So
I do have a question.
Go ahead, Michael. Yes.
So I know that for the NSF fellowship, you can have a proposal that is used for, you know, getting whether you're judged on, you know, that's how you get judged. If you're already in a graduate degree program, like, does that have so I know you were saying some people say that this is too related to what you're already working on. Like that actually kind of confuses me a little bit, because you're already in a degree and now you need to write a paper with a proposal, and it just seems a little bit confusing. How do you orient that? So
yeah, totally. Sorry if I was a little confusing. I did a lot of theoretical stuff with DRT in my undergrad, and that's what and since this is a continuation of DRT as a theoretical model, that's what they were talking about. Sorry if I confuse you a little bit.
No, maybe my question's too vague. So like my thought process is I haven't done anything specifically towards what I want to do in a graduate program. But if I was to start my graduate program and start working on what I want to work on, and then I need to write something for the application, could I write what I'm working on, or would it make sense to do something different?
So, Michael, out of curiosity, what type of program are you looking at?
Right now, I'm looking at the computer vision.
Computer vision? Okay, cool. So some things that I think would be really important to talk about is, so in graduate school, you'll have an advisor, a research mentor. And this is something, a really good conversation to have with them. My advisor really helped me closely with this. I was able to give them a lot of ideas that I had, and they came back with, no, that's a terrible idea. Why would you even think of that? Or, okay, no, this is a really good idea. We could go forward with that. Kind of talking about, since you were talking about that, your research experience is not necessarily what you want to do in the future. Am I getting that correct?
No, so what I'm saying is that, say I already started what I want to do.
Gotcha.
Like, would it make?
Michael, let me help. So that's fine. See that it doesn't have to be like new thing. So you already started, you can write on that. Or if you have a new idea, it's all flexible. So depending on how you demonstrate that you're capable, you will, be successful, you have intellectual merit and, broader impact. So it's not fixed. So, you find the best way to make your case. Okay. So one is before you start. So it can be based on your undergraduate project, and you can write on that, well, this is what I'm going to do for the PhD. Other can be that, well, you already started and this you have already done. Now, continuation of that, I have some new ideas, which will be based on what I have done. Do that, or you can say, well, I'll do completely different. Everything is possible. You just have to convince the reviewers.
Okay, so this leads me to another question. What happens if I have like two separate ideas that I would like to eventually pursue and they're like different?
I would propose which one you think is the strongest idea. So the fellowship is not saying, oh, you can't do any other research. You have to do this. It's not selling your soul to that specific project, right? You could definitely do multiple things throughout your graduate degree. However, you want to showcase that, like, hey, I'm really passionate about this. And this is a proposal that I have that would really reflect me as a researcher. For example, my master's thesis is it's kind of linked, but not really. And then hopefully in the future for dissertation, I would kind of do that project idea, but I'm probably going to be changing it just because trying to get better, different angles, but it's just kind of showcasing that you're able to propose a research project per se.
Yeah, that's a good point. So see that you have to look at what's the best way, if you have 2 ideas, 3 ideas, what's the best way to convince the reviewers that you get it. Then once you get it, there's flexibility, you can change, which is fine. So you're not restricted. So, well, this is what you propose and that's what you have to do. Even when you write research proposals, there's a lot of flexibility because proposal, when you write, you don't know it's going to work and whether all these things you thought is going to work. But as far as you demonstrate that you have advanced a state of art, you have contributed knowledge of science, then that's good. That's fine. And that's a good thing about research science.
Okay, that helps a lot. Thank you.
Okay, who else has the next question? Yes, please go ahead. Robert, how about you? You want to ask more questions? Robert Lake?
No, none of this time.
Okay. So this is a very quiet group. Why don't you got? guys ask some questions.
This is just kind of like a lot to take in right now. I'm just trying to
Yeah,
process
go
it.
ahead.
Yeah, no worries. It's definitely kind of overwhelming, especially with all this
Yeah, there's
information, I bet.
too many presentation. Yeah.
Yeah, I might have questions later. Just right now, I'm so
Yeah.
analyzing things.
No worries at all. That's why I also include my email. So if you're like, this is something confusing or this makes no sense, or please help, feel free. I'm also very willing to send y'all my application and my scores if y'all want a written copy of it rather than just in the presentation. So feel free to just email me. More than happy to help. And also help if you want second eyes to read your application. More than happy to do so.
Yeah, it's good that Angelina showed you her email, so feel free to email her. So can you email me your presentation, Angelina?
Yes,
So
I think I actually already did, but I can do it again.
Okay, yeah, actually you did a couple of days ago, right? Okay,
Yes, yes.
Yeah, remember. Thank you. Yeah.
Right,
thank you very much. Really appreciate it. It's really,
of course.
You know,
Dr. Shaw, I do have one last question, if you don't mind.
go ahead. Yes.
So this is a topic that I've seen touched on once, but never in detail. So the GRE is definitely required for any of these programs, at least at the moment, I believe it is. What is the best way to prepare so that we can achieve the highest scores, that we can get, by working as much as we can? Like, what's the best way to do that? Because I've been trying to research that a bit, and I just wanted to know, what's the best general opinion on it.
Yeah, one is that you have to take several times. Other is that there are coaching classes, there are online support, you practice, there are lots of practice session you can do. Angelina, did you take GRE?
I did. I took it twice.
Mm-hmm.
The first one really big important thing, I think, I know I only have about a minute left, but one big important thing is they also offer financial assistance, which is something I did not know about, which is something I wish I knew about, where you could get money off if you present financial need, which is something really important that I wish was talked about a little bit more. Secondly, I did not do any traditional class. I studied on my own. I might have overstudied because I studied for a few hours a day for a whole summer, and I kind of regret doing that because I do think I overstudied and overstressed. One thing that's really important is the GRE, and this really varies depending on the faculty. So take what I say with a grain of salt, is it's only one piece of the whole pie. They care, at least in my program, personal statements are really important. Letter of recommendation are really important. Your grades in undergrad are really important. How you do on one test, one day, is not going to dictate your whole life. Of course, you want to get above the threshold to enter graduate school, right? And sometimes some schools want higher things, lower things. I know in my program, we offer, a lot of universities will offer what is the average GRE for that program that people get admitted to. I will admit mine was on a little lower side. It was above 300 in both, and I got a 4, I think, on a writing, but it's not amazing. But it was enough to get in, and I also had a really strong undergraduate history. I had a lot of publications, really high grades. So again, GRE is just one little sliver of a big pie.
Yeah, I think that's a good point. That's what Discovery said in the presentation. That is average GRE, average, GPA, but then he did all other things. So you just have to prepare. Okay, well, thank you very much again, Angelina. Really enjoyed your presentation. Good luck on your research. And now next we have Dr. Lee Chong Wang, and thanks for him. He has been sitting here for the whole thing, attending the meeting. So Dr. Lee Chong Wang is a researcher in AI, machine learning, and also a graduate coordinator in computer science. So every department have this graduate coordinator which deals with the admissions, fellowship, and certification of degrees and all those things. And he has been, it's a service, as I said, professor have to do research, teaching, and service. So he has been doing the service for the department. Okay, Lee Chong, it's all yours.
All right, thanks, Dr. Shah. Can everybody hear me and see my screen, right?
Yes.
Okay, yeah. So yeah, this is Li Qianwang, and I'm the graduate coordinator in the Department of Computer Science. So today I will mainly introduce a bunch of program in our department, and we talk about the application and the requirement for each program. First, let me introduce our department. So our computer science PhD program, it is the oldest one in the entire state of Florida. We are the first PhD program at UCF. Our department include 3 National Academy of Engineering Fellow, 6 IEEE Fellow, 1 ACM Fellow, and 2 AS Fellows. So in our faculty, and we have 10 Nfsf Career Awards and 3 Air Force Research Young Investigator Awards. So maybe many students already heard about. So our National Cyber Defense team and Programming Context team get many awards in past few years. And if you go to the HEC building, and you will see lots of the award cups and flags in the hallway. Yeah. So according to the CS ranking, our program is ranked 51st in the entire US. Okay, so it is even better than the state of Florida. Than the UF and FSU. Okay. So in the department right now, Dr. Yan Salihin is a chair. I'm the grad coordinator, and for also the graduate admission and management issue, and Jenny, you can check with Jenny. Our department have a bunch of graduate program. First, we have the PhD program, as Dr. Shai mentioned a lot. Okay, so besides the PhD program, by the way, we have a joint PhD program with the Department of the Statistics. It's called Big Data Analytics. It's mainly hosted in the Department of Statistics. Okay. In our master program, we have the computer science, and we have computer vision, we have cybersecurity, we have digital forensics, and we also have the data analytics. Okay, so this data analytics mainly hosted in our department. Okay, so we have another joint program called FunTech. Okay, together with the School of Business. Besides those graduate program, and we have the certificate program called Mixed Reality Engineering. So it's a certificate, okay? And so the certificate mainly just require you to take a few courses and get the certificate. So besides those graduate program, and we also have the bachelor to master accelerated program. So just now we already mentioned many details of this program. Okay, so here is a current enrollment. Okay, right now you can see that is mainly the data in the last fall. Okay, so you can see we have many undergraduate students major in computer science and IT. Okay, so totally that is around 4,000 undergrad students, and for the master program, and totally we have around 300 graduate students. That's for master program, and for PhD program we have 180 PhD students. Okay, so yeah, we are one of the largest departments in the entire US. So next, I will introduce some research area in our department. So our department have many faculty, and we cover almost every research area in computer science. Okay, first, let me introduce the famous the research area in our department. Okay, as you know, okay, Dr. Malak Shah is leading the CRCV. So that is I think maybe our most famous major or area in our department. Okay, so I don't need to talk about too much details about that. I think everybody knows what's the meaning of the computer vision. Okay, so here just briefly, so mention about it. Okay, everybody already know. Besides computer vision and another major area our many faculty work on is the machine learning and AI. Okay, so besides the computer vision problem, and we also apply machine learning and AI to many other areas. For example, we can use deep learning to handle time series data, and we can do the prediction for COVID-19. And we can also apply deep learning and AI to the robotics. Okay, so there are many very interesting areas. So our faculty are working on. So another research area is HCI, virtual reality and graphics. Okay, so HCI mainly do the research about how human and computer interaction, how design the interaction better. Okay, virtual reality, I think everybody already know. So what is the virtual reality? So right now, virtual reality is an emerging area and has attained many research interest in the past few years. Graphics is, although it's a traditional area, but in the recent years, because the advance of the hardware and the AI, so there are many new algorithms and the research has been done in the graphics. Okay, bioinformatics and system biology, and so people design different algorithms or using the deep learning AI technology and to analyze the genome data and to design the software. Okay, to help analysis lots of biological related data and problems. Okay, so the bioinformatics is also a cluster, and we have several faculty involved in the cluster, and then Dr. Shibu Yusuf lead this cluster. Database and data analytics, and that is also one of the major areas. Okay, so it's a classical research area in computer science, but so we always have a new problem. That's one of the very active research area. And for database and data analytics, and because today we know it is the big data era, and we collect a lot of data, and people design many different new approach to analyze better and get more accurate or extract more information from the big data. So theory, algorithm, and quantum computing. I think maybe many people already heard about the quantum computing. It will be the next generation of the computer. Okay, so Nfsf and the U.S. government has invested a lot of money on the quantum computing, and we expect maybe in not very far, maybe near future, and we can see some real quantum computing will be used to handle the real problems. Okay, so today maybe many people already heard, like Google, IBM already designed some prototype of the quantum computing. Network and mobile computing, that's also classical research area. But in the recent years, we began to use 5G, and we are need much faster and better communication. It's always have new problems to solve. Okay, security and digital forensics, that's also a major area. We have a bunch of faculty work on in this area, and so those faculty work on design different mainly defense problem, and to improve the security and to conduct the digital forensics. So here just a brief introduction about a few major research areas our faculty are working on. So our faculty also involve and lead a few UCF research clusters. For example, Dr. Ian Salikan is leading the cybersecurity and privacy we have a bunch of faculty involved in this area. Another cluster called genomics and bioinformatics, that's led by the Dr. Shibu, and learning science led by Dr. Charles. Yeah, we just give you a brief introduction about our department. And next, let's talk about the requirement and application for our graduate program. First, let's talk about for the BS to MS accelerated program. Just now, Dr. Shah already talked about this program briefly. If you are UCF undergrad student and you have the GPA 3.0 or above and complete at least 60 credit hours and already pass the foundation examination and already finish those computer science 2. So after you finish those, and you will be eligible for the BS to MS graduate program. So this BS to MS program mainly allow you to take up to 12 credits, and those, that's just 4 courses, 4 graduate level courses, and you can use those 12 credits for both bachelor and master degree requirements. So yeah, and after you get in this program, and so feel free to choose. Okay, so usually we prefer, you can take like a 5,000 level graduate level courses, and so but as I mentioned before, okay, getting this program doesn't mean and you will get into the master program automatically. You'll need to apply for master program before graduation. Okay. So that is the accelerated program, and generally for the master program, we need okay, the GPA 3.0, and for GRE, in this year 2021, and we waive the GRE requirement, but from next year, okay, probably we will require GRE. We are talking about, we are discussing this policy, and we will post the policy very soon. Okay, it's very likely, and we will require the GRE. Okay, so if you are not major computer science before, and the student can also apply for the master program in computer science, but we need a student to have some background. Mainly, those students need to take some prerequisites, okay, and show those prerequisites in their transcript. So here I show the 4 requirement courses. In the master program, and we have 2 tracks. The first track we call the non-thesis. Okay, so it's mainly the course based. You'll need to take 30 credit hours. That's 10 graduate level courses. Okay, so within the 10 courses, and there are 2 courses are required, and for all the others, they are elective. So the student not only can take CS courses, but also, and if the students are interested in some other related grad level courses, and we allow students to take up to 2 the 6 credit from non-CS course. Okay, so yeah, so that's some the general details. Okay, so generally speaking, and for the master program, and we require 30 credits. Usually, that's require around 1.5 year up to 2 years. Okay, depends on your progress. So another track for master program called is a thesis based. Okay, so for the thesis based, we also require 30 credit hours, but okay, within the 30 credit hours, you can have the 6 credit research. Okay, all the other requirements the same as the non-thesis option. Only the difference is the 6 credit about the thesis. Okay, so usually students, the thesis mainly, you can do some research with faculty and then write a thesis. Usually students will do that in 2 semesters. Okay, for example, maybe one in the summer and one in the fall. Okay, so yeah, that is for the thesis option. Okay. If anybody have questions, feel free to interrupt me. Okay. So then let's talk about for the PhD program. Okay, the PhD program. Okay, so we have the admission criteria. Okay, so similarly as master program, and we require 3.0 GPA and GRE, no minimum, but prefer the math 160 and verbal is 150. And if you are international student and require the TOEFL. Okay, so although here we mention, we have a similar requirement as a master program. However, usually for the PhD program, the bar is higher because we want we prefer you have a higher GRE and a higher GPA and have a very strong background in your courses and a very strong motivation for research. So for all PhD students, almost all PhD students, and we have the financial aid. That means we will offer GTA or GRA to PhD students. In the PhD program, and totally we require 32 credit hours. Within the 32, that's entire credit hours. Within 32 and 36, is half should be the real courses, and the other half are the research credit. Okay, so in the 36 credit hours, that's 12 courses, and we require you need to take three courses, and for the rest that is for the research. For the PhD program, and usually it will take depend on the progress, usually between 4 and 6 years. I would like to say very few students can graduate in 4 years because that's really based on your background and based on the progress. Okay, so many of our students spend maybe around 5 years or even 6 years with our PhD program. Okay, so in the PhD program, the major goal is to do research. Okay, so but in the first 1 or 2 years, you should take the courses and build up your background and the foundation for the research, and then so after the first 2 years and main focus on research. So there are 4 milestones for a PhD program. The first step we call the qualifier review. Qualifier review is try to is the qualifier review is mainly evaluate your eligibility to continue in the PhD program. Okay, so qualifier review usually was conduct in the 3rd semester or 4th semester in the PhD program. Okay, so after you take courses, and do some research, and we will have the evaluation about it. So right now, our qualifier review mainly is based on the research achievement. Okay, for example, and if we have a good paper published, and then we think, so you're totally qualified for the continue to the PhD program. So that's the first milestone. And the second milestone we call the candidacy. The candidacy will be evaluated, and usually at the end of the finish of the courses. Okay, so after finish all courses and after pass the qualifier review, and you already have some research experience, and we will promote you into the candidacy, PhD candidacy. Okay, so after PhD candidacy, you can register 3 credit hours in each semester, and we will consider that a full-time. And the third step is proposal. Okay, proposal means you already get good experience and good knowledge about research the research area you are working on, and you propose what to do mainly for your dissertation. Okay, so that is a proposal. Okay, after proposal, and you will, reach the end. That is a defense. Okay, so dissertation defense. Mainly, so that is a 4 milestones, and so for those stones, it's mainly will be evaluated by your committee. Okay, the committee member will evaluate your achievement and evaluate your many courses and research achievement, and then decide. So for PhD program, and we allow students to transfer credit. For example, okay, if you already take some graduate level courses in some other institute, and we allow you transfer some graduate level credit to UCF. So if you already have a master program, and you can transfer up to 30 credit hours to UCF. If you don't have the master degree, and you can transfer up to 2 non-credit hours. Okay, as I mentioned, for the accelerated program from bachelor to master, and we allow students to transfer 4 courses. Okay, from the undergrad, from the BS to MS program to your PhD program or master program. Okay, so that's a credit transfer. Credit transfer, we will evaluate every courses you will transfer. Okay, so yeah, when you want to do the credit transfer, you should talk to me and talk to your advisor and see, so we should, make sure that we can find, the corresponding courses in the UCF catalog and do the transfer. So in our program, and we will support, okay, the GTA and the GRA. GTA mainly support for PhD student, and for GRA, most of GRA will go for PhD program, PhD student. But if you are strong in research, and some our faculty will also offer GRA to master program, master student. But for most of master student, and they are working on the hourly TA or hourly grader. Okay, so yeah, so that's some assistantship, and we can offer by our department to offer. As Dr. Sha mentioned, the UCF have fellowships, and you can also apply for some fellowships. Where to find those information for the PhD program? You can find, I attached the link, and you can check more information. For the application, the deadline, okay, most of students, not most, but at least 2/3, students, okay, will apply for the fall admission. Okay, so but we also accept for the spring admission. So here, that is a deadline. The priority just means, if you want to be considered for the like a GRA, GTA, assistantship, we strongly encourage you, okay, submit your application before January 15, if you want to consider about the fall admission. So all documents will be submitted through the CGS website. So here I attach more link, and you can check more information through those website. Okay, so yeah, that's all for my presentation. Any questions?
Okay, thank you, Li Chung. That was very nice, good detailed information about the department, and also all these programs. It was very nice. So do you guys have any question from Dr. Wang? The UCF students can always, go talk to him. But you can also ask questions here. And of course, we want non-UCF students also, welcome to apply, come to graduate school here at UCF. So yeah, go ahead, Michael. Yes.
Yeah, I just have a quick question. I'm already in the BS to MS accelerated program. When I was applying for it, there was something that was very confusing to me, and maybe you could shed some light on this. It referred to like a max credit limit because I'm a transfer student to UCF, and I have a lot more credits than what I need for my bachelor's, and so it had this limit on the website saying that if you have too many credits, you're not applicable or you're not allowed to be in this program. And when I asked questions about it, nobody gave me a straight answer about it, but I was accepted into the program. Maybe you know something about this.
So yeah, thanks for your comments. I will talk to about the college level. Mainly, I think that this program is managed in the college level. Okay, so I do not directly review student application for this. Okay, I will talk to the college level, and yeah, check how they define those policy and make to be clearer to students. Yeah. Thanks.
Okay, because I mean other students might have questions about that too, so I just wanted to bring it up.
Yeah, Michael. So college assistant dean will talk, give a presentation at 4:30. Dr. Ali Gordon. So you can ask him. I think this question.
Okay, perfect. Thank you.
Okay. Anybody else has questions? Okay, thank you very much, Li Chong. So it'll be good if you can email me your presentation, then I'll forward all of these guys.
Yeah, sure. Yeah, I will email you. And yeah, thank you to everyone. And thank you for your attention.
Okay. Okay, so next one we have the third NSF fellowship winner, Brendan. Brendan, so go ahead, share the screen.
Hey everybody, let me actually get the PowerPoint running before I share the screen. And I have closed captions on, but I'm going to turn them off. I can't seem to figure out how to do that, so I'm going to leave them on. Where'd it go? Can everyone see my screen?
Yes, yes.
Yes.
So hello, my name is Brendan Cavanolo. I'm a recent NSF GRFP winner. I won this last year, so 2021. Hopefully I don't kind of repeat what the other NSF winners have said. I'll try to offer a different perspective since I just got it. But a little bit about me first. I graduated with a bachelor's in aerospace engineering and a minor in computer science here at UCF in spring. And I'm pursuing a master's and PhD here at UCF, also in aerospace engineering with a focus in computational fluid dynamics. Currently, I'm in Columbus, Ohio, working at a place called Battelle. They're just kind of a research and development firm that work with customers, and we design products to suit customers' needs. But I've mostly been doing computational fluid dynamics with them. So what is NSF GRFP? Hopefully you guys know by now. It's a graduate research fellowship that gives you $34,000 a year for 3 years, plus $12,000 a year for tuition, fees, other educational expenses. You can use that towards conference travel and technology if you have like leftover money. And you can apply at least twice. You can apply once in your senior year of undergrad, and you can apply once in your first or second year of your grad school. But you can apparently also apply in a gap year if you take a gap year. So that gives you some extra time to build your application. Getting this fellowship usually guarantees funding for your 4th and 5th year at most institutions. And it can even help you get extra funding for your first 3 years as well. So I just kind of wanted to go over a couple of things to do before you apply to this. You guys are already in a great spot since, sorry, I'm getting a phone call. Let me make sure, okay. So you guys are already in a great spot for this since you're in an REU here at UCF. But kind of the first step here is try and find undergraduate work with a professor whose interests align with yours. It's a little challenging, especially if your school doesn't have the resources to help you, but UCF definitely does. We have the Office of Undergraduate Research. We have other programs like Excel and Compass that try to get students very heavily involved with research. So there's lots of different faculty matrices out there that'll help you find faculty who do work that you like. If you don't know what you like yet, just explore. It's a good time to get out there and figure out what you like doing. Once you have a professor in mind and you guys kind of talk about your research interests and you get a project, you want to publish. Get your name on some papers. Conference papers are good. And if you have the option to do an honors and a major thesis, that's also good. They're great starting points. Your ultimate goal would be to get into a peer-reviewed journal. It's very hard to do that as an undergrad. I wasn't able to do it. But if you can, you'll get a very competitive advantage when applying for NSF. But again, honors in the major is a great program, and it really gets you through the whole research process. You write a paper. Mine was around 50 pages. Usually they're anywhere between 30 and 100 pages. And then you get a nice little line on your diploma that says you graduated with honors. So it's pretty cool. And you go through and you edit and you submit to the STARS here at UCF. It's the kind of a database of different research projects that are done here at UCF and published. And they'll go through and look at it and edit it for you and suggest, make sure that your format is what they want. So you kind of get a little bit of a format review, which is nice. And then you go and actually submit it and it's there for people to look at. So people can search for it on Google or Google Scholar, find it, download it, and that gets you, valuable credit to your name, I suppose. Getting citations early on is a real advantage. But yeah, as you're doing this, you're trying to find a research topic that interests you, especially for grad school. And you want to find a niche within your niche, kind of. So I ended up doing computational fluid dynamics, but within computational fluid dynamics, I'm working on multi-phase physics. So you kind of have to find your niche to the niche, and that will help you push the envelope of your field a little bit in that specific area. So the application has a few different components. You have the research proposal, you have your personal statement. For these, you definitely want to use NSF's templates. They're set up in such a way that as long as you just delete what they have and put in what you need, it keeps the format consistent, because they do have very specific format requirements for what you submit. So if you use their templates, you are far less likely to get denied because of your format, your text size, or the way your headers are or anything. So make sure you do that. It will probably get you past 10% of the application. Other components, you need 2 or more recommendation letters. They highly encourage you submit at least 3. And then there's the central dogma of NSF, which is your intellectual merit and your broader impacts. Those were kind of explained earlier, but your intellectual merit is, are you capable of pushing the envelope of your field? Can you contribute a lot to your niche? Your broader impacts are you capable of contributing to society and like making a change? And that's, again, sort of different from just in your field, right? So in my example, it would be, my proposal involved airplane safety when it comes to sand and volcanic ash. So I'm promoting public safety with my application, and that kind of was a benefit in my end. Another important note here is read NSF's program solicitation for the year you're applying. Every year they look for specific topics that they're trying to fund. And if you can tailor your application to what those topics are, you are more likely to get the fellowship. So your research proposal, I just took this image off of Google because I didn't really know what to put here, but 2 pages, including an overall plan for your potential research project. You kind of want to break it down into your intellectual merit and your broader impacts. So in your intellectual merit section, you introduce the project and develop a brief high-level methodology. So again, you're not going into the nitty gritty here. It's important to do the research and get everything right, but you don't need to go into what's the exact physics of what's happening. Give them an equation that says this is sort of the governing equation for this, or whatever applies to what you're doing. You don't want to go right into super detail. You'll run out of room very fast. So, you know, kind of, I laid mine out with an introductory paragraph and then a paragraph for each step in the research. So I kind of broke mine down into different steps, where step 1 would be make the model. Step 2 would be apply the sand to the airplane. And step 3 would be compare this to experimental data. Something like that. Obviously, it was a little more complicated than that, and yours should probably be a little more complicated than that. But if you break it down into steps and you make sure you bold and underline the main ideas of your points, that'll help the reader understand what you're trying to say. Broader impacts, here you kind of evaluate how your project would impact your field and society as a whole. Again, I talked about mine already, where it would be the impact of sand on an airplane. If we can understand that better, we can promote better aircraft safety. Do something like that for your broader impact section. And you want to save room on this for citations. NSF doesn't have a specific format requirement for citations, but I definitely recommend just keeping it simple and keeping it consistent. If you have one citation in MLA and one in APA, they're going to look at you like you're crazy. So I would recommend actually using the citation that your field uses most. For me, it was the AIAA citation style. So you guys probably have something that you would use. Your personal statement, it's 3 pages, and this is kind of where you share your story. This is similar to a college application, but obviously a lot more in depth. And you still want to break this down kind of into your intellectual merit and your broader impacts. In your intellectual merit, you want to tell the reader what motivates you, how you got where you are, and you talk about the challenges you had to overcome to get where you are. And obviously, a big contributor to your intellectual merit is your accomplishments. So you want to summarize those in a way that kind of fit into your story. Well, I took a chronological approach to this. I kind of started where my interest in my field began and got down from there up through high school, up through college, talked about everything in order. I talked about my involvement with student-related student organizations that have to do with my field. If you're a UCF student, you know about the Students for the Exploration and Development of Space at UCF. If you don't, I highly recommend you look into them. They're a great club. And if you like space and space projects, they're definitely looking for computer science people. So I recommend it. Anyway, definitely include experience related to those organizations on this section. And any outside things you've done, such as internships or anything else, put those here. Any research you've done that, if like you can't really talk about your accomplishments in research on your research proposal, so talk about them here. Any like undergraduate fellowships or undergraduate scholarships you got should go here, and that'll make you look good as well. And any publications you got should also go here. They're going to you have to put those on the rest of the application as well. There's a space for it, but if you put it here, you make sure your reviewers read it. And then your broader impacts in your personal statement. This is kind of how do you plan to make an impact on the world using the knowledge from your field? Some ideas here are talking about STEM advocacy. We heard earlier, NSF is very big about STEM. What did you call it earlier? SMET? No, STEM's better. So definitely talk about STEM advocacy if you can. Talk about any service projects you can do related to your field. Something like that. Propose like a personal project that has something to do with your field. My idea was to use aeroacoustics and 3D printing to help visually impaired people visualize CFD models. If you can do something like that, again, if you put it in there, you're not necessarily tied to having to do it, but if you can put that in there, it shows that you can think about a problem that could benefit society and think about a way to solve it. And that looks good. Another thing I haven't mentioned yet is to look for winning applications on Google. There's lots of them out there. That's what I did, and it helped me a lot. You can use them for inspiration. So you can see how people organize their research proposal and their personal statement, and it can help you immensely. Another big part is the recommendation letters. You guys have already heard about these. NSF requires at least 2, recommends 3. You can do up to 5. But again, I recommend doing it 3. Get at least 2 from people who know you and your research. Some ideas there, your lab's principal investigator, any committee members you had on your honors thesis. Again, another reason to do an honors thesis is you get committee members that can write recommendations letters for you. Another idea is to do ask your postdocs if you have any postdocs in the lab you work in. And if you've worked with them a lot, they'll write you a recommendation letter if you're nice to them. Any other professors you've worked with outside your lab? My lab does a lot of work outside of our lab because often what we end up doing is solving problems from our end for a different lab. So let's say there's a lab that has to do with structures. We need to talk about the fluid structure interaction with computational fluid dynamics. So there's lots of different ways you can branch out and work with other labs outside yours. Make sure these recommenders read your proposal and your personal statement. They can be that way, everything looks consistent and they're not like contradicting you in any way, or you're contradicting them. This way they can also speak to your specific skills. It's just important. It makes everything look coherent to the reviewers. If you run out of research related recommenders, I would recommend looking around for other university members, faculty members. A student, if you're part of a student organization, especially if you're part of their elected board or a project lead or something, reach out to the advisor and let them know, hey, I'm looking for a recommendation. Obviously, you have to know them. Make sure you're talking to them and everything. But even if you don't know them super well, they'll ask you, yeah, this would be great. Can you help me write this for you? And then it's a dialogue. You want to have an open dialogue with these people. If there's any other administrative staff that you know well enough, ask them. I was on President's Leadership Council here at UCF, so I could literally ask Dr. Cartwright for a recommendation letter if I wanted to. But again, any other administrative staff like that you know well enough because of programs you're in, ask them. They'll do it for sure if they like you enough. Mentors, if you're in a mentorship program and a professor or an industry professional knows you, ask them for one. I had one of those on mine. And if you've had an internship or a job, even if you worked at Publix, ask your boss at Publix and they can write you a recommendation letter. But I definitely recommend, if you had an internship, and ask your boss for a recommendation letter from your internship. That'll look the best, especially over your boss at Publix. After you apply, it's kind of a long waiting process. And some people earlier talked about how you can use NSF to kind of get into whatever school you want. And it's kind of true, but unfortunately, because of the time window here, a lot of schools make decisions about, a lot of applications for schools are due before NSF is due. So you have to decide what schools you're going to apply to. And sometimes you kind of need to assume that you're not going to get NSF. So it's a little hard there to, if I knew I was going to get NSF, I would have applied to MIT, Caltech, all these other schools. I didn't know, so I kind of played it safe. It's up to you what you can do there. If you can afford application fees for all these schools, go for it. But play it by ear, and also look for schools who have very flexible application deadlines. UCF definitely does, and that's very helpful. But after you apply in October, continue applying to grad schools if you need to. If you've already applied to the ones you want to go to, great. And if you win, which I hope you all do, if you apply, you should definitely apply. You'll have decisions from the grad schools you've applied to by the time NSF makes a decision. You now have a negotiation tool. Pick your top schools and start negotiating your stipend and your lab placement. For example, if school A offers you a better stipend than school B, but you like school B better, share details of your offer from school A with school B. they might be able to match it. This is just kind of a game you have to play. It feels kind of wrong, but sometimes you got to maximize your gains here. And that's just a fact of life. If you don't win NSF, don't sweat it. You'll have valuable feedback on your application and another year to build it as well. The reviewers do such a great job of looking at your application and providing feedback. They give you at least a page of feedback on your application. And that's on both your personal statement and your research proposal. So one thing I recommend, if you don't win NSF the first time you apply and you apply again, do not submit the same exact application. I've seen several people do this. My boss at Battelle did this and he did not get it. So don't submit the same exact application the second time, change it up, make a new proposal. You'll have learned a lot more in that other year. So you want to really just completely start from scratch. You'll have a lot more experience. And that's kind of everything I have. Are there any questions for me? I know I speak very fast. So if anyone needs any kind of clarification about anything I said, just let me know.
Okay, thank you, Brendan. It was very, very nice presentation. Thanks again, because you are out of town doing your internship there in Ohio. So it's good that you took your time off and are able to do this. Do you guys have any questions from Brendan?
I do happen to have a question.
Yes, please.
So this is specifically about letters of recommendation, and it's kind of a general question to anyone that can answer it. One thing that I've read about in books for applying for PhD is that when you do the letter of recommendation, that you should select the option where you don't get to read the letter of recommendation. And the reasoning behind this, they said, was that some schools will not accept applications where you don't choose the option where you can't read what the recommender wrote. Is there any opinions on this? I'm very curious.
A lot of several of the applications I looked at, it was either you submit an application that you can't see or you don't submit an application. It wasn't really like a drop-down list where you can choose to view it or not. It was, I waive my right to view this, and then you submit your application. So sometimes they just don't give you a choice, which is fine.
Yeah, so I think it's not important that you are able to see it or not, because firstly, you should be thankful somebody's going to write a letter for you. And of course, if somebody agreed to write, then it should be positive or neutral. But it's rarely the case that's a negative. So, and different people have different kind of criteria, who write letters. Some people who write letters, they don't want you to read, and some actually students, they don't want to read it, because they feel kind of embarrassed or about that, because the recommender will talk about their praise that, and some people don't feel comfortable with that. So main thing is that you do good work and find somebody who's willing to help you, and then hope for the best.
Okay, that makes sense. The only reason why I brought it up is because it after reading that book, it felt kind of like a gotcha when UCF says, do you want this option or not? So I was just curious what you guys would say.
Yeah, it's just under the law. I think they have to do it, but I think you should always say you are waiving. So that's better. Okay, so any other question? So Brendan, who's your supervisor? Whom do you work under in computational fluid dynamics?
I work with Dr. Kinzel in the computational fluids and aerodynamics laboratory.
I see. Okay. Yeah, because there's a lot of relevance to that computer science, particularly computer vision. we look at the flow of the people as a, liquid flow.
Right.
We model the crowd movement and all this thing, look at the Lagrangian dynamics and all those things. So it's very, very relevant, and different forces we model and so on.
And recently, there's a lot of open source computational fluid dynamics codes that have come out, and they're very, very programming heavy. So I'm glad I have that computer science minor.
Yeah. So do you guys look at like a video and so on, images, or not really?
Sorry, can you repeat that again?
Do you look at the video of the flow, or
Yeah. We usually what we look at is, we have obviously all the calculations going on in the background, but we usually use Star CCM, which has a nice viewer, and you can see all the 3D and 2D flows and everything.
So one thing we use is optical flow, which computes the motion at each pixel in image in a frame and gives you a vector, and you can use that to find some coherent flow and so on. So it's pretty interesting work, I think, in that area.
Yeah, I've also seen a lot of newer research being done in CFD to implement machine learning, and it greatly decreases computational costs. That's nice.
Yeah, and you can simplify the equations and all those things. You can just learn these kind of things, because some of these equations are nonlinear. It's very difficult to solve them, but if you have a data, then you can model these pretty well. Okay, anybody else has a question, any comment? Okay, so Brendan, can you email me your presentation, because I will share with them. And
absolutely.
Yeah, thank you again. It was very nice, and good luck on your PhD. So this will be your first year or second year of your
first
PhD?
year?
First year. Oh, okay, yeah, very fresh. Okay, great.
Right.
So you did the honors and major thesis, right? That's what you're saying?
Mm-hmm.
Yeah, okay. And
yeah, I can't recommend that program enough. Not only does it give you a lot of research experience, but you also get opportunities for very specific scholarships that will obviously give you more funding, and they're really good. Yeah,
I think several of our students have done in the past, but recently I didn't have anybody. So yeah, all the UCF students are encouraged to do this. You can take your RU project and can expand this, make it thesis, and I think it's the way it works that you have to do 1 or 2 courses like independent study, and then it's a thesis, and it's a pretty nice way, give you a distinction.
Mm-hmm. A lot of times you can use those 2 courses as elective credit as well. Mm-hmm. You do have to pay for them though, so that's kind of the hurdle, but yeah.
And you don't have to have honors student, because honors, you can come to UCF and come as honors student and from the beginning, but this honors and major thesis, anybody can do that as far as you have advisor and you have research project. So that's a great idea. Okay, great. So thank you. So now we have one last presentation from our Associate Dean, Dr. Gordon. So I think he should show up in a few minutes. So you guys are getting ready for the poster session and the spotlight. So there a lot needs to be done in the report. So Robert is working with you. Robert, you have a meeting with them on Wednesday or something?
Yes, sir, that's correct. We have
Yes.
a meeting on Monday.
Mm-hmm. So this week is busy for you because it's the last week, and that's why we have canceled these meetings, the weekly update meetings this week, so you can have more time to work on these things. So anything else, Robert, you want them to do? And they're meeting with Dr. Swan on next week, is that right?
Yes, sir, that's on Tuesday.
Tuesday, and then what else? Then
We have a virtual banquet dinner on Monday.
Monday,
Yes, sir.
and then there's a party on Saturday.
For the local students, we'll have a party at Dr. Shaw's house to celebrate you and Krishna's graduation.
Yeah.
So just a heads up to everybody, all of our students. The time for the meeting on Wednesday will either be 2 p.m. or 6 p.m. So I'm going to poll you after this meeting here. And then in that meeting, we're going to go over everything that's happening in the next couple of days, plus our rehearsal.
Mm-hmm. And make sure that you have all these weekly presentations from everybody. Because
that's a good reminder to the students, because I have almost everyone's, but for these last couple weeks, I haven't looked at the last week, for example. Make sure you have all the presentations uploaded to those directories I've shared with you.
Okay. Okay, Dr. Gordon is here. Hey, Ali, thanks for taking your time. And I know you are busy. So many departments to take care at the college level. So go ahead, you can share the screen.
Okay.
So,
okay, can you hear me?
Yes, I can hear you. Just share the screen.
Okay,
So,
can you see? Let me know if you can.
I can see, yeah. So we are very happy to have our Associate Dean, Dr. Ali Gordon. He's a professor in mechanical and aerospace engineering, and he deals with all the engineering and computer science departments at the college level, all the related affairs of graduate program, the certification, the fellowships and admission and all kinds of things. So Ali, it's all yours now. You take over.
Okay. Well, look, I just want to thank you all for allowing me to have some space here to chat with you about graduate programs in general, but also graduate programs that within CECS. And in my role here as Associate Dean, it's my job to try to bring on the next group of students here, grad students at least, for a variety of our, almost a dozen PhD programs, dozens of master's programs, and other opportunities that we have for grad students. So what I normally do with speaking with groups of students like you is to welcome them for what we call an open house, and we welcome them. Well, a few years ago, we would welcome them to campus to come in and visit and see our facilities and meet with our faculty and talk with some of our current students. Now we kind of do it virtually, and so this is what we call our open house, and I'll give you a taste of what we do during those open houses, and this will just give you a sense of of how we like to reach out to students. And if you have any questions about the grad programs in CECS, I'll be glad to to talk to you about them. But I'm sure through your program here in computer vision, you've had a chance to learn a lot about CECS and its grad programs, but maybe I can fill in some of the gaps. So I do want you to hear more about the benefits of grad school, and of course, if you have any questions, I'd be glad to really answer them. You know, we have a variety of, you know, we have a, just under 2,000 grad students. Hopefully we'll cross that number this fall. We'll cross over 2,000 grad students enrolled in our grad programs. And we have them, they come from a variety of places, a variety of fine institutions across the world, across the US, and just across our state. And really they make for a great and wonderful environment that allows our classrooms to be vibrant, our research areas to be vibrant spaces. So, but you know about UCF already. So let's just say that, you know, if you haven't learned, UCF was founded in 1963 as Florida Tech, and really it was founded to help with the burgeoning space program that was happening just down the road. And so, you know, we served, Kennedy Space Center, Cape Canaveral Air Force Station, and we served their needs by providing educational opportunities for the employees there. So there were classes that were available to them, or we were training what would be future employees to go and work there. And so we have a strong connection with not only those folks that are out there in Kennedy Space Center, but we have strong connections with folks that are in industry in general. So that's kind of part of our DNA is working with companies, working on teaching, instructing their future or current employees, but also solving some of the technical challenges that they have. There's a hotbed of technology that is in the Central Florida region, and many of those folks who are in the region, essentially they look to UCF to help them solve problems, whether it's with staffing or technical challenges. So we have a variety of really good, excellent graduate programs here, doctoral programs. We've always been, you know, an innovative university, you know, and we're also, you know, internationally known for our computer science. So it's good that you're a part of that program. You know, when I joined at around the 2006 timeframe. I was a grad student. So this here at UCF, this has been my first job. Hopefully it'll be my last job here. And the campus looked like this back then. This was 2007 timeframe, and so you can see, you know, actually I can see, you can't see, but I can see a variety of the construction projects that were happening around that time. When I look at some of these surface lots here, parking areas, you know, there are buildings in many of these spots. I know Dr. Shaw can testify here. There are new buildings here and new buildings that are over there. They say that we're under construction forever, and that's because we continue to invest in our campus, and there's just been such growth here. And it's been driven by the growth in the state and just by some of the excellence and some of the achievements that we've been able to make as a university. So when I give these kind of talks to students, to prospective students, I often show some of the maps. So here are some maps that we often have that gives you a sense of where students are coming from. So when I had this meeting a few weeks ago, you could see, you know, we had students interested in a variety of countries, not just the U.S. but from a variety of different continents. You can see that on the plot on the right, you can see that they're coming. We've got interest from students who are all over, pretty much all over the U.S. And this is just for one meeting that we happen to have this summer. And so there's people who are all over the country. They recognize us. They know that we're here. They know that we're doing some great things, and they want to join us. When we have these meetings, also, we get a variety of students who have undergraduate degrees or in undergraduate programs or even graduate programs in institutions throughout the state of Florida. Here are the seals for a variety of the institutions that are in Florida, and we've had visitors at our open houses from all of these states. We have a variety of great institutions in the state of Florida, and we're excited that so many of them are interested in entrusting us here at UCF with their future and the next step in their academic development. So, okay, so you've been here, all summer, serving in your, in your REU program. I'm gonna point you to some of the fast facts that we have here. And so here are the ones that are most relevant to CECS. There's the one on the left. It really gives a good indication of our first destination survey for graduate students. And it will show you, and the links to each of these are underneath, but they basically say that if you get a graduate degree from CECS, there's 39 out of there's a 19 out of 20 chance that you're going to be doing something that's related to your area. Okay, which is a very high number, so 95%. Most of our students are employed by the time that they are finished, or they have some kind of offer by the time that they finish. But there's a small number here that I think is really, really important to us, and something that we like to tout, especially to our students who are from out of state. If you want to have a job in the state of Florida, in the technical industry, you can come to a place like UCF. You can come here for your graduate degree, and there's a 72% chance that you will have that you will be employed in the state of Florida. Just because there's so many companies that are here, we're so connected with those companies that they're often emailing. I have HR people, I have points of contact that are engineers, VPs that are always emailing me. If I know students that would be a good fit for a said position that they might have there. So not just me, but also other faculty and other people in our college that they're reaching out to them. Our graduate population continues to grow. Our college continues to grow. We've got a lot of great things that are happening. We've got a lot of great facilities that are here. And these documents, they give you some of the fast facts, some of the things that are helpful, might help you make a decision on what you might do in the future, and gives you more information about UCF. I've talked about the companies that are in the area, and this is from these plots come from Enterprise Florida, and basically they give a map of some of the companies that are in our state by industry. So on the right, you'll see the aviation and aerospace companies that are there. So you can see that there's a plethora of companies that are not just in our region, but also pushing down towards the end of the peninsula, the Miami area. This is why UCF is the #1 supplier of talent to the aerospace and defense industry, because we're close by. We have a lot of students that are coming here. We got excellent programs, but also there are a number of other types of industries where that are also really rich in our state. So Infotech is there. We've got companies that are in defense, manufacturing. I could be naming healthcare. I could be naming things like the theme park industry. There are a variety of there's so many companies that are here. There's so many employment opportunities that are here that our grad programs, our alumni tend to saturate, these companies, and they know that they can find the future talent by coming back here. So that's kind of how that works. As far as grad programs here in our college is concerned, I'm sure you already know that there are a variety of different graduate degree program types. So there's the PhD programs, there are master's programs. We also have certificate programs. But I believe after having an REU experience like you've had, you probably are going to be interested in the PhD program, perhaps the master's program as well. I'm not sure, but a variety of students that I've had in my own REU have elected to go on to PhD programs. My guess is that by being a part of your RU program, that getting into your RU program was probably more difficult than it was to get into a PhD program, because RU programs are pretty tough to get into in general. So with regards to the various degree programs that we have here, you know, the next degree for an undergraduate student, it tends to be an MS degree. And there are two different types. There's a non-thesis and a thesis option that you can do. And but someone who's interested in research is usually going for the thesis. And a thesis carries 30 credits. And so for that, you know, we're talking about 10 classes. And two of those classes usually are connected to the research that you're doing. So most students can finish this program within 4 or 5 semesters. For the PhD program, so if you are continuing on, you can take those 30 credits and apply them towards the district, towards your PhD. And typically the PhD program is either a 4 or 5 year program, but you cut out time based on if you come into it with a master's or not. A variety of our students are choosing to join these days, either as face-to-face or in the online modality. Some students, I've had my own students who are here on campus face-to-face, and they enjoy taking the courses online because I think that they might be able to view and rewind and archive what's happening, the lectures, what's happening in class a little bit more easily. So anyway, moving on. CECS has a variety of graduate programs, and I know that I'm talking to a bunch of computer scientists, and maybe the engineering programs are not as of interest to you, but taken as a whole, you know, our engineering and computer science programs that we have, what it really does is it creates a really collaborative, interactive environment where you have students who are collaborating across academic programs. We have a variety of students here. Because we have so many students, there are a lot of features, there are a lot of different programs that we can, a lot of different benefits that we can share across the various students that are enrolled in these programs. And so it really allows you to really dabble in other areas that you might be interested in. So for example, we often have mechanical engineers taking electrical engineering courses. It's not uncommon to have a computer science student taking a computer engineering course, or someone who is doing a research project in civil and environmental engineering, collaborating with someone in material science and engineering. So by having a variety of degree programs that are here, it really benefits all of us here, okay? Because it creates that many more opportunities for collaboration. The other thing I want to point your attention to is the fact that, you know, we've got degree programs that are on the way. You know, we've got new degree programs as well. So computer vision is our newest MS program, which I'm really excited about. And then we also have cybersecurity and privacy. So these are new programs that are happening. Our curriculum is on the move. And not only is it on the move, but the way that these programs are really architected is such that we are very collaborative with our industrial partners, so that when they're crafted, they really keep an eye on making sure that the program content is inclusive of very contemporary content that is needed to really solve problems that are out there in industry. So anyway, so those are some of the programs that we have, and I always love talking more about these programs with prospective students. And if you have any questions about them, I surely be able to answer them for you. But you should know that there are a variety of benefits by being in the grad program, right? So you get a chance to advance your own skill set. Maybe there are courses that or concepts that you weren't able to get as a part of the undergrad program that you really would like to get, and you can get them in a grad program. So you can get, you know, tangible technical skills in a grad program that might be more elusive to you elsewhere. You have improved communication skills. I mentioned the MS thesis program that you could be participating in. Well, the MS thesis program, you have to write a thesis. You have to display. You have to communicate your ideas, your concepts to others. You have to present your ideas to others. Those are really things that are going to help you out later on in your professional career. Many students choose to get a graduate degree because it makes them a stronger candidate for a leadership position. You know, if you go to many companies, especially many large ones, you'll see that some of the leaders there, either technically or on a managerial side, have graduate degrees. So a graduate degree is a way that you can boost your own value. So there are things that are happening inside the classroom and also, you know, outside the classroom. You know, you're going to be interacting with your peers. You have an enhanced network. I know for sure that I continue to talk with people who I took grad school courses with. We continue to be great friends to this day. You might be the first person in your own family to get a graduate degree. That's a good reason to go to grad school, for the personal achievement of it. This list goes on, so I could talk more and more about these things, but you know, I often try to give examples of students who have gone off to do great things. So here's a student who is actually coming from an international university, you know, got their PhD here, has gone on to be a faculty member at another university. So someone like this, you know, could be you. You could be someone who comes here for a graduate degree, you know, gets involved in writing papers, gets involved in research and presenting posters at conferences, and likes the academic environment so much that they want to continue on in that space. The other thing I didn't mention is there obviously there are going to be monetary benefits of going to grad programs. Here's our this comes from our first destination survey, and generally it shows that there's a $10,000 a year difference in the salaries that our alumni are able to make if they're able to have an advanced degree. So 10,000 for a master's, 10,000 more if you are a master's if you're a PhD on average. But that's just 1 year. So if you invest in yourself, then if you count that $10,000 that you have in salary difference between your degree, you know, if you were to add those up over your 30-year career, that's enough to buy a plane or two, right? That creates some real generational wealth that you might be able to really do some good with. And so statistics show that people who have a bachelor's degree tend to earn $2.3 million over the course of their career, but a master's degree nets you so much more, and a PhD nets you even more than that. That's enough to buy a beach house. That's enough to put a number of your kids through college. Okay, so these are things that are tangible outcomes of a graduate degree, is that you have a significantly higher earning potential. The other thing I often like to mention is the fact that people who have advanced degrees often have much lower rates of unemployment, because if you get a job, you know, with a graduate degree, you become someone who's a lot more valuable in their company, and so they're less reluctant. They're more reluctant to let you go. So job security is an important issue. Of course, you're going to have access to softwares and other things that you can tinker with as a part of being in the graduate program. These are usually these softwares that you are using in the grad program are available to you either for free or at a significantly reduced cost. So here's a chance for you to continue to tinker with those software packages and platforms that are out there that can really add real strength to your toolbox. Okay. Other things that we have that are kind of unique to our grad program here at UCF and CECS is that we have a variety of professional development opportunities. So the university has workshops that you can attend, okay, that are really designed for grad students in general. They talk about how to mentor an undergrad student or how to write a technical paper or things like that. And then there are things that we do in the college in CECS that really help CECS students. We talk about going after faculty positions or going after postdoc positions, or we have alumni panels that come back and talk about students about their experiences in industry. So there are things that we do to help try to really develop a well-rounded individual. Okay. So funding is also important, and I think that was a topic that you all talked about a little earlier. If you want to get, go for a fellowship like that and you're not able to bring one in, I think that's okay, because we have courses that are designed to really help students to really develop strong applications. I know that Dr. Weishample was a presenter earlier. Maybe he talked a little bit about this course that we do, and the success rate tends to be around 1 in 4. So if you take the course, you have a really good chance at winning a fellowship, which is really good. This is geared towards our PhD students. Okay. And so you've been around Orlando in the summer, so maybe you've had a chance to go to an amusement park or see some of the other things that Orlando and Central Florida has to offer, the beaches, or maybe you've seen a rocket launch. These are some of the things that our students who are already here have the pleasure to enjoy on a regular basis. So, again, we try to make well-rounded students, so it can't be about all work. There has to be some play in there. You have to enjoy the environment that you're going to be a part of for a few years. So, okay, so that's really my spiel, as it were. And we're going to have another graduate open house day that happens early in the first week of October. If you want to learn more, and we meet for about 2 hours each time. We talk a little bit more about our programs in general, and I'd love for you to join back. If you follow the link at cecs.ucf.edu/grad day, we'd love to talk to you more, keep the conversation going. We have workshops that are designed for prospective master's students, also PhD students, and students who are thinking about other programs that are a little bit outside the norm, so like executive programs or programs that are newly launched. So I'd love to see you there, and you can register for it at this website below. Okay. One of the other things I want to talk about here is what you can do as a next step. You have because by virtue of the fact that you've been working with a faculty mentor this summer, you already have contact with a faculty member. So you're in good shape there, okay? But normally, what many of our students do is to, if they're interested in being involved in a grad program, they'll reach out to faculty. We don't just apply, but we also try to develop a good relationship with a faculty member beforehand. So my colleague Michael here and Michael Kinzel here in mechanical engineering is a good example. So if someone is interested in his research, what they would do is find him on the website, look to see what research he's doing by reading papers, looking to see what equipment is in the laboratory, what skill sets are needed to be successful in his laboratory, and then reaching out to the faculty member to learn more about what it would take to be involved in research as a grad student in his lab. Okay, so these are things that I think you can do very easily. You've worked with a faculty member, you've conducted undergraduate research, but now it's time to maybe think about what you're going to do as far as grad school is concerned. So you often start with faculty. So reach out to the faculty whom you want to work with. Okay, so I think that's it. That's all I really wanted to talk about. And getting admitted to graduate school, it takes effort. It's not something that you can really do overnight. Okay, you have to develop a plan of and some motivation for putting together your application, because there's so many things that are required. There are letters of recommendation that are required. There are essays that you need to write. You need to give your basic information. You need to develop a CV or resume. All these things are very important, and you can't hope to do them overnight. But my advice that I always give to students is to really figure out what's your motivation. Why go to grad school? What is it for you? Is it the personal achievement? Is it because you want to improve your technical skill set? Identify your reason and figure out what your future goals will be, and grad school can be a part of that. Communicate with your graduate programs director. So for those of you who are interested in coming to CECS and being a part of computer vision, for example, you talk to Dr. Shaw, talk to Dr. Lobo. They can tell you more about the grad program really directly. And they can tell you whether or not you're a good fit for the program. But I'm sure if you're in the RU program, I'm sure you already are. Develop a roadmap to get you there. Figure out what all the deadlines are, and please let us know if you have any questions about our grad program. So it's something you can do. It's something that we have at least 2,000 students doing this fall 2021 is going through our grad program. So there's no reason whatsoever why you couldn't be one of them. So I think with that, that's all I wanted to talk about. I think I'm out of time anyway. I would certainly like to keep the discussion going. And if you're not able to attend our fall grad open house day, don't worry, because we actually have them 3 times a year. So once in the spring, once in the summer. And hopefully I'll see you at one of them, and we can talk more about how we can see you here in the future. Okay. So with that, let me turn it over to you all. I don't know if you have any specific questions that I can answer for you.
Okay, thank you. Thank you, Ali. That was nice presentation and overall bigger view of the college, different programs. Yeah, do you guys have any questions from Dr. Gordon? Michael, you had some questions, right, about the transfer credits you asked Li Chuang Wang. You can repeat here.
Yes, sir. So I applied to the BS to MS accelerated program. And when I was doing that, there was a confusing thing that came up. It said that there was because I'm a transfer student to UCF, I have more credits than what I need for my BS. And one thing it mentioned on the requirements thing was that you cannot have more than a certain amount of credits. And I asked a few different, I sent emails and asked a few different people, and I couldn't really get a clear answer. They basically just said, don't worry about it. But I was just wondering why that's on the website if it's so confusing. So.
First of all, the BS to MS program is probably, it's one of our most exciting graduate programs here in the college. It's also the one that is probably evolving the most because every student is really representing a special case, right? Because no 2 students are alike in this case. And so, what we often tell our prospective BS to MS students is to come and talk to Miss Nina Leonard. And what she'll do is she'll take a close look at your academic program, and she'll look at your credits to see exactly where you are. We have to be very careful about, and on the grad side, we have to be very careful about what we do, what we can subject a student to as far as their undergrad program is concerned, because the undergrad programs, tend to be a lot more heavily regulated than the graduate programs are. So there are ABET requirements that are there, and so we need to make sure that you're doing everything you need to do to satisfy the undergrad side. And so the way the BS to MS program works is that you can really only, make use of at most 12 credits for for the master's program that are kind of dual counted. So you could have situations where you might not have enough elective credit left to be able to dedicate towards, that 12. But that doesn't mean you can't be a part of the MS to the accelerated BS to MS program. What I would do is if I were you, I would come to one of our info sessions, and you can learn a little bit more about it there, or just go to the Grad Day website and you can find some of our old slides there. And you can see what's there. But
I just want to clarify, I have been accepted to the program, and I've already taken classes that are higher levels. So but I was just confused, and I thought maybe other people could use this information. So
yeah, okay.
Okay, great. So any other question?
Do you have an email for Ms. Leonard? Because I'm interested in the.
Yeah. What I'll do is I'll put it in the chat here before I go.
Okay, thank you so much.
Okay.
Yeah, Ali, it'll be good if you can email me your slides, because I'm going to send a copy of all presentations to this group.
Yep. Okay. Fantastic. I will do that. Okay. Well, thanks, Dr. Shaw, for the chance to talk with your really bright and really talented group of REU students.
Okay. Well, thank you very much. So we will hopefully invite you next year. So we'll continue like that. Okay. Bye. So I think we are done with all the presentations, and this 30 minutes was, if you guys have any remaining questions to discuss before we end. So anybody has any comments, questions? There was a lot of material, and as I said, I will send you all these presentations. So there's a lot of duplication, but that's fine. So we are trying to do our best to help you guys, and it's up to you how much you want to benefit. But as you saw, that there's a lot of rationale for you guys to consider going to graduate school, seriously, and depending on your interest. And of course, I mean, you don't have to do in computer vision, because you got exposed to you. If you're interested in some other area, that's fine. So, but do think about that what you want to do next after you finish your BS.
Dr. Shaw, I do have a quick question.
Yeah,
I am interested in the class for the applications for the PhD thing. Does anyone remember the name of that? Maybe they could put it in the chat or something.
Yeah, I think it was in this Dr. Weinschempel's presentation. Is that a course you're talking about?
Yeah, that's the one.
Yeah, he has sent me the presentation, so I'll send you, all of you guys. Otherwise, you can just send him email. So there is he said there's a 0 credit hour course. It will be in the schedule. You don't have to pay, but they prepare you for that. And also, as they mentioned, there's this office where they have all this information. That was what was it called? Prominent graduate office or something. So that is the right place to start at UCF. And I'm sure that there will be similar offices in other universities. So that is listed in John's presentation. So once I send you, you can look at that. And I think this office is in the administration building where the president offices and so on, financial aid, and all this, they have different offices. Okay, so who else has any comment, question?
Well, if nobody else has anything, Dr. Shaw, I'd just like to say that, I've been to several of these things over the years, and I thought the speakers did so good today. I thought we got so much good information.
Yeah, I will agree. I think this was really good. Thanks to all the speakers, they are all volunteers. And this was very good. And we are recording, and that we will also provide so you can watch it again. But this combination of the fellowship winners, then graduate coordinator, and as Dean of College of Graduate Studies, and also from the College of Engineering and Computer Science, all this was very nice. So thank you again, and good luck on your posters and spotlights and reports. So we'll
If I real quick, Dr. Shaw.
Yes.
Leave me out, Chu Chin, and Ethan Thomas. No, Ethan Thomas, you voted. Michael Brown, maybe. If you would please go on Slack and vote for the time that I've posted now, that'd be great. Thank you.
Okay, bye. So we'll end here.